Welcome to our Kubernetes full course. If you are new to Kubernetes, it's a tool that helps manage and scale containerized applications, making it much easier to deploy and handle applications in different environments. Kubernetes has become essential in the tech world because it automates tasks like scaling, managing, and maintaining applications, so teams can focus more on deployment. In this course, we'll start the basics of Kubernetes architecture and gradually move into advanced topics like Docker networking, Kubernetes versus Docker, and setting up with Docker Compose. Whether you're exploring Kubernetes for the first time or building on your Q skills, the course has everything you need to get started. Also, if you're looking forward to make a career in DevOps, definitely check out Simplilearn's professional certificate program in cloud computing and DevOps. This comprehensive course offers in-depth learning with a thorough understanding of cloud computing principles and DevOps practices guided by expert instructors with real-world experience. You will engage in hands-on projects and the real-world scenarios, building a robust portfolio that showcase your skills. Plus, the program is designed to help you gain industry-recognized certifications, making you a standout candidate in the job market. Don't miss this opportunity to advance your career and stay ahead in the ever-evolving tech landscape. Check out the course link in the description box and pinned comments.
Back in the day when Netflix was just starting to hit its stride, they faced serious challenges managing their growing infrastructure. Keeping millions of people happy, streaming movies and shows without interruption, it was not an easy task. Initially, Netflix struggled with scaling issues, monolithic architecture problems, and deployments bottlenecks. Their infrastructure couldn't keep up with the increasing user demand, leading to frequent downtimes. The monolithic architectures made it difficult to update or scale parts of the system without affecting the whole. Deploying new features was slow and risky and often causing service disruptions. And that's when they discovered microservices, which allowed them to break the application into smaller and more manageable pieces. This meant that they could tweak and tinker with different parts of the service independently, and greatly improving flexibility and reliability. Complementing microservices with DevOps practices like continuous integration and deployment, Netflix transformed their operation, ensuring seamless streamings for users worldwide. So next time when you binge watch, remember this epic journey they took to get there. Now before we move on and learn more about DevOps, I request you guys that do not forget to hit the subscribe button and click the bell icon for further updates. So here's the agenda for our today's session. We are going to start our session with an introduction to what is DevOps. Then we will learn about why DevOps. Moving ahead, we will discuss principle of DevOps and phases of DevOps. Then we will deep dive into DevOps tools. And finally, we are going to conclude our session with a hands-on. So guys, let's start with what is DevOps. Guys, DevOps is an innovative approach to software development and IT operations that emphasizes collaboration, automation, and continuous improvement. The goal is to bridge the gap between developers who write the code and operations who deploy and manage it, leading to faster, more efficient production cycles and deployments. So this was a basic definition of DevOps. Now, I hope so you have got a brief idea regarding this. Now let's move on and understand why DevOps. So guys, understanding its impact on traditional software development and shift to microservices, DevOps has become an essential methodology in modern software development, primarily addressing many of the inefficiencies found in traditional development and operation model. These traditional models often feature siloed structure where development and operation teams have distinct, separate roles and responsibilities. This separation can lead to various challenges like the slow production cycles. With development and operations working separately, the transition from code completion to deployment can be slow and cumbersome. There is a lack of integration between these teams and often result in longer release cycles. Next issue with the traditional setup was the deployment issues. When developers and operations work independently, there is a higher chance of encountering problems during deployment, such as configuration errors, environment discrepancies, and unexpected behavior in production. And also they had limited feedback loops. Like in the traditional setups, feedback from the operation teams regarding application performance, user issues, or system failures might not reach to developers quickly, and thus delaying the necessary fix and improvement. Now there was an introduction of microservices where we got enhanced scalability, increased development velocity, and flexibility when compared to traditional setups. Now let's look at a case study of a financial firm and how DevOps helped them. So guys, consider a financial firm who is struggling with the deployment cycles and poor feedback mechanism in their traditional development setup, leading to delayed product updates and frequent outages. So what's the solution? As we have discussed earlier, microservices. In DevOps culture, so as a solution, they implemented a DevOps culture fostering closer collaboration between developers and operation, and also establishing a continuous integration and continuous deployment pipeline. By the adoption of microservices, they split their large cumbersome financial processing system into smaller and manageable microservices. And what's the outcome, guys? The continuous improvement. The CI/CD pipelines allowed for regular updates and minimal downtime. Each microservice could be updated independently and facilitating faster and safer deployments. There was enhanced feedback loops. So monitoring tools specific to each microservice provided rapid feedback directly to the respective development teams, which allowed for quicker responses to the issues and more informed decision making. So this was the overall benefits of applying a DevOps culture in a financial firm. And they had two success outcomes. The first one was they adopted a DevOps culture, which helped them a faster delivery, and there was adoption of microservices, which helped their applications succeed and also improve the user experience. Now let's move on and try to understand that what are the principles of DevOps. So guys, the core principle of DevOps are laid as follows. Initially, DevOps is founded on several key principles that streamline and enhance the processes involved in software development and operations. The first one is automation. Second one is CI/CD. And the third one is rapid feedback. Now let's understand each one of them one by one. Now if I talk about automation, guys, so automation in DevOps covers everything from code deployment to environment setup and network configuration. For example, using a tool like Ansible, you can automate the deployment of application across hundreds of servers, eliminating manual setup and ensuring consistency across your infrastructure. Next one we have is continuous integration and continuous delivery. Let us first discuss about continuous integration. So here, developers merge their changes back to the main branch of the project as often as possible. These changes are validated by creating a build and running automated tests against them. For example, using Jenkins, a CI server which automatically tests the build whenever new commits are pushed to the main repository, ensuring that new code integrates well with the existing code base. Now, if I talk about the continuous delivery, guys, it extends the continuous integration by automatically preparing and tracking a release to the production. This ensures that you can release new changes to your customers quickly in a sustainable way. For example, Travis CI can be configured to deploy applications automatically to the production environments. Whenever the build stage in the CI process is successful, it is provided by all the tests that it has passed. Now let us discuss about the third one, that is rapid feedback. So guys, what does it involve? It involves implementing feedback mechanisms quickly and identifying and addressing issues in the development or production environments. For example, we have New Relic, which can be used to monitor applications in real time, providing immediate feedback to developers if performance degrades or an error occurs. So these were some of the basic principles of DevOps. I hope so you got an idea regarding this. Now let's move on and discuss one of the most important points, that is phases of DevOps. So guys, if we discuss the phases of DevOps, understanding the life cycle in DevOps is crucial to grasp how it benefits the software development and operation process. And you should understand one thing, that DevOps is not a tool. DevOps is a practice that we apply in our software development. So the first one is plan. The planning phase involves defining the project scope, identifying resources, and scheduling timelines. For example, Jira for task management and sprint planning, which helps in tracking the progress and prioritizing the work items. Next we have all over here is code. Developers write code in small, manageable chunks to ensure that integration is simpler and more frequent. For example, we are using GitHub, a version control system where developers can collaborate to track changes and revert to previous states if necessary. The third one is build. The build phase involves transforming code written by developers into a runnable instance of the application. For example, Gradle or Maven, which can compile code and manage the dependencies. The fourth one is testing phase. Automated tests are run to ensure the application behaves as expected. For example, Selenium for automated web testing and ensuring that user experience is consistent across different devices and browsers. Next one we have is release. So guys, the release phase involves activities related to deploying the software to production, ensuring that the software is released in a controlled manner. For example, Docker, which can package the application and its environment into a container that can be deployed consistently in any environment. The next phase is deploying. The actual deployment of the application to a production environment where it can be accessed by the users. For example, we use tools like Kubernetes, which automates the deployment, scaling, and management of the containerized applications. Seventh one is operate. Ongoing maintenance and regular updates of the application are happening at this stage. For example, we have Ansible for configuration management, ensuring that all systems are consistent and maintained in the desired state. And finally, it's monitoring. Continuous monitoring of the application to ensure it performs optimally and to detect and resolve issues as they arise. For example, we have Prometheus for monitoring application performance and Grafana for visualizing the data collected. So these were some of the phases of DevOps. So guys, in the interviews, someone can ask it. So just keep a thorough note of this. Now let us move on ahead and understand DevOps tools and their capabilities. For example, we have the version control system. Version control systems like Git allow the teams to track changes and revert to previous version of their work and manage code with a minimal conflict between the concurrent efforts. For example, we have the tool like Git, which allows to do version control system. Next, we have CI/CD tools. So guys, we have CI/CD tools like Jenkins, CircleI, GitHub Actions, which automate the stages of CI and CD, facilitating the frequent and reliable code changes by automatically compiling, testing, and deploying the code. Then we have the configuration management, where we have tools like Puppet, Chef, and Ansible, which automate the provisioning and management of your computing infrastructure and application. They ensure environments are set up consistently and are repeatable. Moving ahead, we have monitoring and logging. So guys, tools like Elasticsearch, Logstash, and Kibana, and also Splunk collect, analyze, and visualize machine-generated data to provide insights into application performance and health. So guys, these were some of the DevOps tools. And I hope so you have got a brief idea like how they are incorporated in DevOps. Now let's move ahead and do a small hands-on and let us see how can we incorporate these tools into DevOps practices. So guys, let us create a hands-on beginner DevOps tutorial where we are going to set up a basic continuous integration and continuous deployment pipeline using GitHub Actions. And in this tutorial, we are going to show you how you can automate the testing and the deployment of a simple Hello World Python application. Now, there are certain prerequisites for this. You need to have a GitHub account and have a little bit basic familiarity with Git and Python. You can access any text editor like VS Code or Sublime Text. Now, let us go on to the step number 1. Let us first create a new repository on GitHub. Okay, so I have logged into my account, okay, and here I'm going to click on the new. So here's our new repository, and our repository name is going to be, let's say, Hello World CI/CD. So Hello World CI/CD is our Git repository. Now make sure that you make it public. Okay, that's very, very important because now initialize a repository with a README file. So here you can add a README file all over here. And also you can set up a description that this is a demo CI/CD project. Okay. Now, since you have done all this thing, just click on create repository. So our new repository is going to be created. Okay. So it says the world is not familiar. Okay. We are going to change the name. Say hello world. Okay. Now let us create the repository. Pretty fine. So you can see our repository is created. Now, let us do one thing. Now, we are going to set up our local environment. For that, you need to have a git bash in your system. Now, let us clone the repository. Okay. So, what we are going to do, so let us copy this. Okay. And let us go to our bash, and here let us first create a directory. So let us create mkdir and let us give a name of CI/CD, or we can say it demo. Okay, then let's move to that directory. Okay, pretty good. Now in this I want to clone it up. So for cloning you need to do just add git clone, okay, and add the given link. Pretty fine. Now just click on into it and you can see it has started cloning the given directory. Now let us move to this directory, which is hello world. Okay, so I'm just gonna copy this and say cd, let's paste this. Okay. Now you can see we are in our main branch. Now all over here, so as you can see we have navigated to this directory. This is our main, and cd hello world is our main parent branch. Now after that, what you have to do, let us create a basic Python application. Okay, so I have already created that for you. So you can see there are two files. First one is app.py and second one is test-app.py. So this is a hello world CI/CD. Okay, but we need some different directories. So let us open the folder first. Okay, let us see. Okay, we can see demo here. Okay, so you can see we have opened our directory hello world all over here, and here we are going to create a file name app.py inside this repository. So no worries, just click on this folder and click app.py. Okay, and this is our app.py, and inside this let us write a Python code. So basically let's create a function, say def hello world. Okay, a function that just prints hello world. And inside this, I want to say let's return hello world. Pretty fine. Now let's move ahead and let us write our function. So this is very basic. So if name, let's say it's equal to, say, main. Okay, and we can print the hello world. So let us call our function hello world. Now we have created a basic app.py file. Now the next thing what we are going to do, we are going to commit. Okay, so let us add this file. So let us open our git bash and say git, okay, and say git add app.py. So this file has been added, and let us commit a message. Okay, so git commit and m, and let us say add hello world. Okay, so this is our message. Now finally moving ahead, what I'm going to do, so you can see committer, my name is given and your name and email address configured automatically on your username and hostname. So it says, and after doing this, this has been committed. Now let us push this. So git push. So you can see it's easily being pushed up. Now the fourth part is testing. So we are going to create a test file all over here. So basically in this, we are going to do a unit test, and which is going to test the hello world function. So if you are aware of unit testing, it's fine. And if not, you can check on our channel. There are a lot of videos regarding unit testing. It might help you out. So guys, here, let us create this test app.py. Okay. And here I'm just gonna paste this. So it is unit test. You can see I'm importing our application app, and here is hello world is imported from this file, and here the class test app is there, and here basically we are doing a unit test. So in this I'm asserting that hello world is, whenever we are calling this function, it prints up the hello world. And finally we are defining our main function. Very easy. And after this, let us add commit to this file. Okay, basically to our repository. So what we are going to do, we are going to add this file in our repo. So let us control, pretty fine. Now let us git add, and we can test app.py. Okay, it says our app file is not named like this. Let me check. So test app.py. Okay, is it inside this directory? Okay, something is wrong. So no worries, I have okay. Now in here, I'm gonna okay guys, so my file was out of the repository, so I included in this. Okay, now let us go to our terminal. Okay, and let us retry to add. Okay, now you can see this would be easily committed. Now, and after this, let us commit it. So git commit m, and let's say add test for hello world application. Okay, and let's just click on it, and you can say this is committed. And finally, we'll push it up. So you can see it has been easily pushed up onto our repository. Now, the step 5 would be creating a GitHub action for CI/CD. So let us navigate to our repository first, and if you refresh this, we could see we have added a readme file, app.py, test app.py. Okay, now in this repository, we have to navigate to the actions tab and click and create a new workflow. Okay, so here you can see this actions button. Just click on this. So in this, let us set up our new workflow. Okay, so basically we are going to create, like, the file would be main.yml, and YML file that you have to put all over here. So let me share you with this. So guys, as you can see, this is our main.yml file. Okay, and the content inside this looks something like this. Okay, so you can see all over here. Now let us try to understand this file. So basically you can see the name of this application is Python application CI/CD. So we have created a workflow file for this. So it says on. So basically on defines the event that is going to trigger the workflow. Then you can see there is push. Basically this workflow will trigger on the push events to the main branch. Then you can see there is a pull request, and the workflow will also trigger on the pull request to the main branch. So basically these triggers are going to ensure that every push and pull request to the main branch initiates the workflow, which is common practice to ensure that the main branch remains stable and deployable. Now you can see all over here, there are jobs. Okay, so like build, YML, copy code, jobs, and these things are there. So basically jobs defines a set of jobs that the workflow will execute. Jobs run in parallel by the default unless it is specified. Now you can see build, this is a single job and it is identified by the key build. It includes several steps that this job will execute. Then you can see runs on. Okay, so this specifies the type of virtual machine to run the job on. So here we can see that here is the machine is Ubuntu latest. It basically indicates the latest Ubuntu runner which is provided by the GitHub action. Then there are steps. So inside the steps you can see we have the users written actions / checkout at v2 name setup Python, and there are users action setup Python v2 with Python version 3.8. Now here you are going to install your dependencies, then you are going to run, and finally we are installing Python m pip install upgrade pip. So basically steps, what does it mean? It's a sequence of tasks that will be executed as a part of the job. Okay, in the users action / checkout at the rate v2, basically this step uses the checkout action to check out the repository code so that the workflow can access it. Okay, then we are setting up Python 3.8 and it uses the action setup @ Python version v2. Basically, it is initializing the setup Python action to set up a Python environment with specified parameters to pass the action, such as the version is 3.8. So this overall sets up the Python version 3.8. Then we are installing the dependencies. So there is a run command. So basically it executes a command using the shell in the run environment. And this script updates the pip and install the unit test module, although which is typically unit test is a part of Python standard library and it does not require installation via pip. Okay, that's one additional thing I want you to know. And finally, we are testing our application with the unit test. Okay, so this step runs the Python's unit test module in the discovery mode to find and run the test. Then there are vflag, which is for the verbose output and which is going to display all the tests being run on their results. So this configuration ensures that every change that we are pushing to the main branch or made in a pull request is automatically tested. And it is maintaining the code's integrity and functionality. The CI/CD pipeline helps automate the testing and the deployment. It is very essential practice for efficient and reliable software development and which is generally followed in the industry. So I hope so you have got a brief idea regarding this. Now we have completed our setup. So what's the next thing we have to do? So we have to go all over here and just click on commit changes. So it says create via main.yml and we can see that we have created this. So guys, as you can see in this main.yml, you can see we have created our workflow all over here and we have created our CI/CD pipeline using the GitHub Actions for the simple Python application. This pipeline automatically runs your test every time the changes are pushed to your repository, demonstrating a foundational DevOps practice. This fundamental step towards more complex DevOps processes involves larger applications and more integrated testing and deployment environments. So guys, this was a basic CI/CD setup. I hope so you have got a brief idea regarding this.
If you are here, you're probably wondering how to become a DevOps engineer. Well, you are in the right place. Today, we are diving into the ultimate DevOps Engineer Roadmap. DevOps is all about blending development and operations to streamline and speed up the entire software development process. DevOps engineers are in hot demand and the salaries are pretty amazing too. Depending on your experience and where you are, you could be making anywhere from $90,000 to over $150,000 a year. So stick around. In this video, we'll walk you through the ultimate roadmap to becoming a DevOps engineer. We'll cover everything you need to know step by step to help you succeed in this fantastic field. So these are the contents that you must learn to become a DevOps engineer. So better take a screenshot of this. Also, if you are looking forward to make a career in DevOps, definitely check out Simplilearn's professional certificate program in cloud computing and DevOps. This comprehensive course offers in-depth learning with thorough understanding of cloud computing principles and DevOps practices, guided by expert instructors with real-world experience. You'll engage in hands-on projects and real-world scenarios, building a robust portfolio that showcases your skills. Plus, the program is designed to help you gain industry-recognized certifications, making you a standout candidate in the job market. Don't miss this opportunity to advance your career and stay ahead in the ever-evolving tech landscape. Check out the course link in the description box and pinned comments. So let's get started. So first up, we have the Software Development Lifecycle or SDLC. So the software development lifecycle is a process used by the software developers to design, develop, and test high-quality software. It consists of several stages. Each stage helps ensure the software is reliable, functional, and meets user needs. So understanding SDLC is crucial because it gives you a holistic view of software development. It's like knowing the recipe before you start cooking. So the different phases of SDLC are requirements gathering, understanding what the stakeholders need, design, planning the solutions architecture, implementation, which is writing the code. Then comes testing, which is ensuring the code works as intended. Then comes deployment, which is releasing the software to users. And finally, maintenance, which is updating and fixing the software as needed. So each phase has its own importance, and knowing these phases helps you understand how DevOps practices integrate to make the development and deployment processes more efficient and reliable. So next, let's talk about Linux. Linux is a type of operating system like Windows or Mac OS that runs on many servers, computers, and devices around the world. It's known for being stable, secure, and free to use. But why Linux? Because it's the backbone of most server environments you'll work with. Here are the essentials you should focus on, which are command line operations, shell scripting, learn bash to automate repetitive tasks, system administration like understand how to manage users, permissions and processes, and package management. So Linux is used everywhere in the server world, and knowing it well will help you fix problems, automate tasks, and manage servers easily. Now the next one is learning a scripting or programming language. So knowing a scripting language like Python, Ruby, or even Bash is essential. These languages help you automate tasks, write scripts, and manage infrastructure. So here's why you should learn scripting. Automation. Write scripts to automate repetitive tasks such as backups, deployments, and monitoring. Configuration management. Tools like Ansible use Python for automation. Infrastructure management. Use scripts to manage cloud resources, databases, and more. So choose a language and start building small projects to get hands-on experience. I highly recommend Python due to its simplicity and extensive libraries. Now, Git is next on our list. Git is the most popular version control system out there. It allows you to track changes, collaborate with others, and maintain a history of your code. So key concepts to learn include repositories, how to create and manage them. Commits, recording changes to the repository. Branches, which is working on different features simultaneously, and merging, which is integrating changes from different branches. So familiarize yourself with platforms like GitHub, GitLab, and Bitbucket. These platforms facilitate collaboration and code management in a team environment. Now, networking and security are critical components of a DevOps engineer's skill set. You'll need to understand how data flows through networks, how to set up firewalls, and secure your applications. So, focus on these areas. Basic networking. Understanding IP addresses, DNS, HTTP, HTTPS, and TCP/IP protocols. Network security. Learn about firewalls, VPNs, and encryption techniques, and application security. Implement security best practices such as input validation, authentication, and authorization. So this knowledge will help you build secure and reliable systems, ensuring data integrity and confidentiality. Now let's move on to cloud providers. So AWS, Azure, and Google Cloud Platform are the big players here. So start with one and learn the basics. So number one, compute services like EC2 AWS, VMware in Azure, and Compute Engine in GCP. Then comes storage services like S3 in AWS, Blob Storage in Azure, and Cloud Storage in GCP. And then database services like RDS in AWS, SQL Database in Azure, and Cloud SQL in GCP. So understanding cloud services is crucial as most modern applications run on cloud infrastructure. So learn about IAM, which is Identity and Access Management for security, and explore cloud-specific services and tools offered by these providers. Now next, you need Infrastructure as Code, or IAC, which is a game changer. So infrastructure as code is a way to set up and manage computer resources like servers and networks using code instead of doing it by hand. So you write scripts that describe what you need, and then tools like Terraform or Ansible read these scripts and set everything up for you automatically. So this makes it easy to create, update, and keep everything consistent every time. This means you can version control your infrastructure just like your application code. So the key benefits include consistency, which ensure that environments are identical. Then scalability, it easily replicates environments across multiple regions. And then version control, which track changes to your infrastructure over time. So you can start by writing simple Terraform scripts to provision resources, or use Ansible to automate configuration management. Now next up, we have microservices and containers. So microservices architecture allows you to break down your application into smaller independent services. So containers with tools like Docker package these services and their dependencies, ensuring they run consistently across environments. So you should definitely focus on microservices, which is understand the principles of designing and building microservices. Then Docker, learn how to create Docker files, build images, and run containers. And then container registries. So use Docker Hub or private registries to store and share images. So these concepts will help you build scalable and efficient applications that are easy to deploy and manage. Now following containers, we have container orchestration. So Kubernetes is the go-to tool here. It manages the deployment, scaling, and operations of containerized applications. So the key components that you need to learn of Kubernetes are: number one, pods. The smallest deployable units that can contain one or more containers is called pod. Next, services. Networking components that define a set of pods and a policy by which to access them. And then deployments, which are controllers that manage the desired state of pods. So learning Kubernetes can be challenging, but it's incredibly powerful. It automates many operational tasks, allowing you to focus on building great applications. Now moving on to next, continuous integration and continuous deployment, or CI/CD, are at the heart of DevOps. So tools like Jenkins, Circle CI, and GitLab CI help automate the process of testing and deploying code. So here's why CI/CD is crucial. Continuous integration automatically tests your code to catch issues earlier. Continuous deployment. It automatically deploys your code to production, reducing time to market. And then pipelines. It defines the steps to build, test, and deploy your application. So mastering CI/CD will make your development process more efficient and reliable, allowing for faster and more frequent releases. So next, monitoring and logging. So monitoring and logging are essential for maintaining and troubleshooting your applications. So tools like Prometheus, Grafana, and ELK Stack, which is Elasticsearch, Logstash, and Kibana, provide insights into your system's performance and help you diagnose issues. So you must focus on metrics, which is track performance metrics like CPU, memory, and network usage. Logging. Collect and analyze log data to troubleshoot issues. Alerting. Set up alerts to notify you of potential issues before they become critical. So by setting up proper monitoring and logging, you ensure your systems run smoothly and can quickly respond to any problems. So now, DevOps is not just about tools and technologies. It's also about people. So collaboration and communication are crucial. You'll be working closely with developers, operations teams, and other stakeholders, which mean you must definitely focus on communication tools, like start using Slack, Microsoft Teams, or other tools for effective communication. Then comes project management, so utilize tools like Jira or Trello to manage tasks and projects. And then you must develop soft skills, so develop empathy, active listening, and clear communication to work effectively in a team. So being able to convey ideas clearly and work effectively in a team is a key to your success in DevOps. So finally, let's talk about leadership and strategy. So as you grow in your career, you may take on more responsibilities and lead teams. So understanding the strategic aspects of DevOps, such as implementing best practices, driving cultural change, and aligning DevOps initiatives with business goals is crucial. So focus on best practices. Implement and advocate for DevOps best practices within your team. Next, cultural change. Foster a culture of collaboration, continuous improvement, and learning. And then strategic alignment. Ensure DevOps initiatives align with business objectives and deliver value. So leadership skills will help you inspire and guide your team towards success, making a significant impact on your organization.
We're going to break up this presentation into 4 key areas. We're going to talk about life before Kubernetes, which some of you are probably experiencing right now. What is Kubernetes? The benefits that Kubernetes brings to you, particularly if you are using containers in a DevOps environment. And then finally, we're going to break down the architecture and working infrastructure for Kubernetes so you understand what's happening and why the actions are happening the way that they are. So let's jump into our first section of life before Kubernetes. So the way that you have done work in the past, or you may be doing work right now, is really building out and deploying solutions into 2 distinct areas. One is a traditional deployment where you're pushing out code to physical servers in a data center, and you're managing the operating system and the code that's actually running on each of those servers. Another environment that you may potentially be using is deploying code out to virtual machines. So let's go through and look at the 2 different types of deployment that you may be experiencing. When you have applications running on multiple machines, you run into the potential risk that the setup and configuration of each of those machines isn't going to be consistent and your code isn't going to work effectively, and there may be issues with uptime and errors within the infrastructure of your entire environment. There's going to be problems with resource allocation, and you're going to have issues where applications may be running effectively and not effectively, and not load balanced effectively across the environment. The problem that you have with this kind of infrastructure is that it gets very expensive. You can only install one piece of software, one service on one piece of hardware, so your hardware is being massively underutilized. This is where virtual machines have become really popular. With a virtual machine, you're able to have better resource utilization and scalability at much less cost. And this allows you to be able to run multiple virtual machines on a single piece of hardware. The problem is that VMs, or for virtual machines, are not perfect either. Some of the challenges you run with VMs is that the actual hardware and software needed to manage the VM environment can be expensive. There are security risks with VMs. There are security risks with VMs. There have been data breaches recorded about solutions that run in virtualized environments. You also run into an issue of availability, and this is largely because you can only have a finite number of virtual machines running on a piece of hardware. And this results in limitations and restrictions in the types of environment you want to be running. And then finally, setting up and managing a virtualized environment is time consuming. It can take a lot of time, and it can also get very expensive. So how about Kubernetes? Well, Kubernetes is a tool that allows you to manage containerized deployment of solutions. And inherently, Kubernetes is a tool that is really a next level maturity of deployment. So if you can think of your maturity curve as deploying code directly to hardware in a data center, and then deploying your solutions to virtual machines, the next evolution of that deployment is to use containers and Kubernetes. So let's kind of go through and look at the differences between a virtual machine and Kubernetes. And we've got a few here that we want to highlight, and you'll get an understanding of what the differences are between the two. So first of all, with virtual machines, there is inherently security risks. What you'll find as we dig through the architecture later in the presentation is that Kubernetes is inherently secure. And this is largely because of the legacy code, the legacy of Kubernetes and where it came from. And we'll talk about that in just a moment. But Kubernetes is inherently secure. Virtual machines are not easily portable. Now, with that said, they are technically portable. They're just not very easily portable. Whereas with Kubernetes, it's working with Docker container solutions. It is extremely portable. That means that you can actually spin up and spin down and manage your infrastructure exactly the way that you want it to be managed, and scale it on the demands of the customers as they're coming in to use the solution. From a time-consuming point of view, Kubernetes is much less time-consuming than with a virtual machine. A few other areas that we want to kind of highlight from differences. Virtual machines use much less isolation when building out the encapsulated environment than Kubernetes does. For instance, with a virtual machine, you have to run hypervisor on top of the OS and hardware, and then inside of the virtual machine, you also have to have the operating system as well. Whereas in contrast, on a Kubernetes environment, because it's leveraging Docker container or container-like technologies, it only has to have the OS and the hardware, and then inside of each container, it doesn't need to have that additional OS layer. It's able to inherit what it needs to be able to run the application. This makes the whole solution much more flexible and allows you to run many more containers on a piece of hardware than versus running virtual machines on a single piece of hardware. So as we highlighted here, VMs are not as portable as Kubernetes, and Kubernetes is portable, directly related to the use of containerization. And because Kubernetes is built on top of containers, it is much less time consuming because you can actually script and automatically allocate resource to nodes within your Kubernetes environment. This allows the infrastructure to run much more effectively and much more efficiently. So this is why, if we look at our evolution of the land of time before Kubernetes, why we are running into a solution where Kubernetes had to come about, because the demand for having more highly scalable solutions that are more efficient was just just really a natural evolution of this software deployment model that started with pushing out code to physical hardware and then pushing code out to virtual machines and then needing to have a solution much more sophisticated. Kubernetes would have come about at some point in time. I'm just really glad it came about when it did. So what is Kubernetes? Let's dig into the history of Kubernetes and how it came about. So in essence, Kubernetes is an open source platform that allows you to manage and deploy and maintain groups of containers. And a container is something like Docker. And if you're developing code, you're probably already using Docker today. Consider Kubernetes as the tool that manages multiple Docker environments together. Now, we talk a lot about Docker as a container solution with Kubernetes. The reality is that Kubernetes can actually use other container tools out there, but Docker just simply is the most popular container out there. Both these tools are open source. That's why they're so popular. And they just allow you to be able to have flexibility in being able to scale up your solutions. And they were designed for the post-digital world that we live and exist in today. So a little bit of background, a little bit of trivia around Kubernetes. So Kubernetes was originally a successor to a project at Google, and the original project was Google Borg. Google Borg, it does exactly what Kubernetes does today, but Kubernetes was rewritten from the ground up and then released as an open source project in 2014 so that people outside of Google could take advantage of the power of Kubernetes containerization management tools. And today it is managed by the Cloud Native Computing Foundation. And there are many companies that support and manage Kubernetes. So for instance, if you're signing up for Microsoft Azure, AWS, Google Cloud, all of them will leverage Kubernetes. And it's just become the de facto tool for managing large groups of containers. So let's kind of step through some of the key benefits that you would experience from Kubernetes. So we have 9 key benefits. The first, it is highly portable. It is 100% open source code. And this means that you can actually go ahead and contribute to this code project if you want to through GitHub. The ability to scale up the solution is incredible. What's the history of Kubernetes being part of a Google project for managing the Google network and infrastructure kind of really sets the groundwork for having a solution that is highly scalable. Out of the high scalability also comes the need for high availability. And this is the desire to be able to have a highly efficient and highly energized environment that also you can really rely on. So if you're building out a Kubernetes management environment, you know that it's going to be available for the solutions that you're maintaining. And it's really designed for deployment. So you can script out the environment and actually have it as part of your DevOps model so you can scale up and meet the demands of your customer. Then what you'll find is that the load balancing is extremely efficient, and it allows you to distribute the load efficiently across your entire network so your network remains stable. And then also the tool allows you to manage the orchestration of your storage. So you can have local storage such as an SSD on the hardware that the Kubernetes is maintaining. Or if the Kubernetes environment is pulling storage from a public cloud such as Azure or AWS, you can actually go ahead and make that available to your entire system. And you can inherit the security that goes back and forth between the cloud environments. And one of the things you'll find consistent with Kubernetes is that it is designed for a cloud-first environment. Kubernetes as well is that it's really a self-healing environment. So if something happens or something fails, Kubernetes will detect that failure and then either restart the process, kill the process, or replace it. And then because of that, you also have automated rollouts and rollbacks in case you need to be able to manage the state of the environment. And then finally, you have automatic bin packaging, so you can actually specify the compute power that's being used from CPU and RAM for each container.
Do you know, friends, that Kubernetes is also called K8 or Kube? It is an incredibly powerful platform that helps you manage and scale applications automatically. But it can feel complex and overwhelming at the same time. Many people find Kubernetes a bit tricky when they read through the documentation, especially when they are trying to understand how all the pieces fit together to manage containers. In this video, we are going to break it down for you in easy terms. We will explore 2 types of nodes in Kubernetes, the master node and the worker node. We will talk about how these nodes work together inside the cluster to manage and orchestrate your applications. So guys, without further ado, let's get started. So guys, let's start with understanding first what is pod. A pod is the smallest unit in Kubernetes. It is like a wrapper around your application. Inside a pod, there's usually one or more containers. Now you'll be wondering, what is a container? A container is where your actual application runs. It includes everything that the app needs to function, like code, system, libraries, and dependencies. Containers are lightweight and can be easily moved across different environments, making them very popular in modern software development. You can think container like a box that has your app and everything it needs to run. Whether you run it on your laptop or on a cloud server or inside a Kubernetes pod, the container will always behave the same way. Let me give you one example. Suppose you run an online e-commerce store. You have a front-end web app that the customers see and the back-end, the database that stores the product information and orders. In Kubernetes, you might choose to package the front-end and back-end as two separate containers. So you could run both the web app and the database inside the same pod. In this case, both containers, front-end and back-end, share the same resources, such as memory and network. This might be useful if they need to be closely coupled and always run together. Now, pods are basically responsible for managing resources for containers inside them, like the memory, CPU, and storage. And each pod runs on a node, and Kubernetes decides which node will run on each pod. Now, let's understand the Kubernetes architecture. So guys, as we all know that Kubernetes is an open source platform designed to automate, deploy, scale, and manage centralized applications. It provides a powerful way to ensure that your applications are running efficiently and can easily scale across multiple machines, and can also recover if something goes wrong. At the heart of Kubernetes architecture, there are worker nodes and master nodes. These two components work together to ensure your apps are always running smoothly. In this video, we will take a closer look at each of these components and how they interact with each other. So let's understand first the worker nodes. Worker nodes are the machine which can be either physical computers or virtual machines where your applications actually run. Think of them as the workers for your Kubernetes cluster. They execute your app workloads, handle the tasks required them to run. Each worker node in Kubernetes runs these three main processes. That is container runtime, kubelet, and kubeproxy. Let's understand each one of them one by one. The first process is container runtime. The container runtime is like the engine of your worker node. It is responsible for running your applications, which are packaged into containers. Containers are basically lightweight standalone units that contain everything your app needs to run. This includes code, system libraries, and dependencies. The container runtime is a software that ensures these containers are properly managed and executed on each worker node. One of the most popular container runtime is Docker, as you can see all over here. So there are two instances of first, there is a my app, which can be a front end. Then you can consider this as the back end. So guys, you can consider something like this. These two as your two containers. This can be a front end, this can be a back end or database. Now there's a container runtime all over here, which can be Docker in this case. So the container runtime in this case is Docker, and it is ensuring that the container for your web app is running on the worker node. So if you have multiple applications, they will be packaged into separate containers, and container runtime will manage them, making sure they are running as expected. The next process that we are going to discuss about is called kubelet. Kubelet is like a manager that oversees everything happening on a worker node. It talks to the master nodes, which are responsible for managing the entire cluster. The kubelet gets instruction from the master node detailing which application or pods needs to be run on the node. It ensures that these applications are running by managing containers inside the pods. Unlike container runtime, which is specific to managing containers, the kubelet handles the interaction between Kubernetes and the worker node. It is responsible for making sure that the right number of containers are running, that the resources like CPU, memory, and storage are allocated properly to those containers. So you can say, for example, we have the master node that sends a request to the kubelet saying run 2 containers for the web app. So one container is there for web app and one is for the database. The kubelet will check the available resources on the worker node and ensures that the containers are up and running. It also continuously monitors the health of these containers to make sure they don't crash or run into problems. If container fails, the kubelet can restart it based on the policies defined in the Kubernetes, ensuring that the application remains highly available. I hope so you would have got an idea regarding kubelet. Now let's move ahead and understand about kubeproxy. Think of kubeproxy as a traffic director for your Kubernetes cluster. In a distributed systems like Kubernetes, your applications which are running on different nodes, kubeproxy is responsible for managing network traffic and ensuring that data is routed correctly between different services and pods. When your application needs to talk with each other, in this case, kubeproxy sets up the necessary network rules and ensures that the traffic flows smoothly between different pods, services, and nodes. It manages the internal networking of the cluster and ensures that each pod has a unique IP address. Now, let's move ahead and understand about the working of master nodes. While worker nodes handle the execution of the application, master nodes are the brain of the Kubernetes system. The master node manages the overall state of the cluster and makes decisions about which application should run and where they should run. The master node constantly monitors the clusters to ensure everything is working as expected. There are 4 key components that make up the master node. The first one is API server. The API server is like the front desk of the Kubernetes control plane. It acts as an entry point for all the requests you send to the Kubernetes. Whether you are creating a new application, checking the status of your pods, or scaling your app, you communicate with the Kubernetes through the API server. The API server handles all these requests and ensures that they are passed on to the correct components within Kubernetes. For example, let's say you want to deploy a new web application in your Kubernetes cluster. You would send a request to the API server, which would receive the request. It will validate it and pass it to the appropriate components, like it can be a scheduler or a control manager. Now, let's move ahead and understand about the second component, that is the scheduler. If I talk about the scheduler, guys, the scheduler is like a smart planner for the cluster. It is responsible for deciding which worker node should run a new application. When you create a new app in Kubernetes, the scheduler looks at all the available worker nodes and determines the best node for the app to run on. Based on available resources like CPU, memory, and network, the scheduler ensures that your apps are distributed efficiently across a cluster so that no single worker node is overloaded. Now let's move ahead and understand about control manager. The control manager is like the quality control department of Kubernetes. It constantly monitors the state of cluster and ensures that everything is running as it should. If something goes wrong, like a pod crashes or a node goes offline, the control manager steps in to fix it. The control manager is responsible for ensuring that the desired state of the cluster matches the actual state. If you define that you want 3 replicas of an app running and one of them crashes, the control manager will automatically create a new replica to maintain the desired state. Now the final component is etcd, which is also called as the cluster brain. etcd is a database that stores all the data about the Kubernetes cluster. It is often referred to as brain of the cluster because it keeps track of everything, including the apps which are running, where they are running, and the overall state of the cluster. etcd is a distributed key value store, meaning it can store data across multiple machines and ensure that it is highly available and fault tolerant. This is crucial for Kubernetes because the entire system relies on etcd to know how the current state of the cluster is. For example, if you want to deploy a new app, Kubernetes stores information about the app, like its configuration, location, and state in etcd. If something happens to the cluster, Kubernetes can recover the current state from etcd. Now let us look at the example of setting up a cluster. Now that we understand how worker nodes and master nodes work, let us go through a simple example of a Kubernetes cluster setup. In this, you have a basic cluster with 2 master nodes and 4 worker nodes running on it. Let us say these pods contain a web app and a database. You start by creating pods, and each pod contains 1 or more microservices for your web app. Then the scheduler steps in. Once you submit the request to Kubernetes through the API server, the scheduler looks at the available worker nodes and assigns both the pods to your worker nodes. Then comes the kubelet, which manages the pod. The kubelet on the worker nodes receives the instruction from the master node to run on the two pods. It starts a container inside each pod using Docker or another container runtime, and it ensures they are running smoothly. Then we have kubeproxy, which handles the communication. The web app pod needs to communicate with the database pod. Kubeproxy sets up the network routes and ensures that the two applications can exchange data securely and efficiently. Then we have control manager, which ensures the stability. If one of the pod crashes or fails to start, the controller manager detects the issue and creates new instance of the pod, ensuring that both your web app and the database stay online. Then finally, we have the etcd, which keeps up the track. All the information about the state of the cluster, including running pods, their location, their status, is stored in etcd. This ensures that the cluster can recover from any issues and always knows what is happening. So this was a simple example illustrating the cluster setup. Kubernetes is a powerful platform for managing containerized application across cluster of machines. By understanding the roles of worker nodes and master nodes, you can see how Kubernetes automates the deployment, scaling, and management of your apps. Hello everyone, and welcome to this hands-on tutorial on Docker Compose. In this video, we will be working with two primary components: a front end built with HTML, CSS, and JavaScript, and a backend powered by Node.js. Docker Compose in this scenario will allow us to seamlessly manage these components and run them in isolated containers, while simplifying the orchestration between the services. In this video, we will explore how to set up a basic front-end and back-end architecture, use Docker Compose to run both services in separate containers, define custom networks so that front-end can communicate with the back-end. So guys, let's get started. Let's start with Docker Compose. So go on the Google and type Docker Compose. So you can see the first link all over here. This is the guide to the official documentation. Just click on this, and here we will be navigated to the Docker Compose official documentation. Now, what is Docker Compose, guys? Basically, Docker Compose is a tool for defining and running multi-container applications. So multi-container in this sense can be your front end or a back-end service. Okay. With Docker Compose, you can use a YAML file, typically which is named as dockercompose.yml, to define multiple services, their dependencies, networks, and volumes in a single configuration file. This allows you to spin up multiple interconnected Docker containers with one simple command, making it ideal for environments where you have complex setups, such as microservices or multi-tier applications like web server, database, cache. So if I talk about multiple container, in this scenario, it can be such as we have these two files, which is a backend file and a front-end file. Okay, so this is a sample setup which I have created for you. We are going to learn about it. Now, as you can see all over here, so in our backend file, we'll be having a node project. Okay, so here are our node modules. We'll have a Docker file and a main file called server.js. Then we will have certain dependencies installed all over here. Okay, similarly for front end, we are having a simple index.html file, script.js, then CSS, okay, then the corresponding Docker file. So as I have told you earlier, that Docker Compose helps us to spin multiple interconnected Docker containers. So here you have one container and here you have one container. Now the Compose is going to run these two containers. So in this scenario, what I was telling. But our question arises all over here, okay? So why do we use basically Docker Compose? So one of the most important reasons what I found out is that first, you have an easier multi-container management. With Compose, you don't need to manually start and link multiple Docker containers. Compose handles it for you. Then you have the declarative configuration. The entire stack or services, networks, volumes, which are very main concepts of Docker Compose, is declared in single dockercompose.yml file. Then you get the environment consistency. You can ensure that development, testing, and production environments are consistent by using the same configuration. And finally, you get simplified commands, which means that you can start, stop, and manage complex application with just few commands. Now, there are certain key concepts. So if I talk about certain key concepts all over here, so our first concept is services. Okay. So basically services are different containers that make up your application. For example, in this scenario, we have a backend service and a front-end service. It can also be a web service, database service, and cache service. Now, the second most important concept that we have all over here is network. So if I talk about networks, guys, so networks in Docker Compose allows you to define how services are networked together. By default, Docker Compose will set up a bridge network so that your services can communicate with each other using their service names instead of IP addresses. And the third thing that we have all over here is volumes. So if I talk about volume, you can define persistent storage volumes in your docker compose.yml file. This is useful for databases or other services that need to persist data across container when your Docker container starts. So these are the certain important concepts, services, networks, and volume, which we'll be seeing in our Docker Compose file. Now, let us set up our workflow. Before that, I want you to have installed Docker Compose on your system. So if you have not installed Docker Compose, go all over here, install. Okay. Suppose you have a Linux system, just click on it. If you have a Mac, then you can click on it. I'm using Windows, so I'll click on this. So now you can install Docker Desktop. So I'm using x86-64 processor, so I'll click all over here. And for the same thing, it requires a WSL. Okay. So you can download this also if you don't have in your system. So guys, you can install Docker Desktop on Windows very easily. The first process you can do all over here. While installing, you can just click all over here and it is going to install your Docker Desktop. So I will not do it since I already have it, or otherwise you can do it from the command line. So you can see all over here that on your terminal you can write Docker Desktop installer exe install, then start process, and then you can copy this code. Very easy process, guys. Once you have installed your Docker Desktop, then you can start creating Docker file and Docker Compose file. But always make sure when you are running your script, your Docker engine should be running. Now let us discuss about basic Docker workflow. Okay. So you need to define, first of all, your environment with docker compose.yml file. So the first thing is define your apps environment, the docker compose.yml file. Okay. So this file will describe the services that need to be started again. Example, your front-end service, back-end service, and a database. The Docker images to use or any specific configuration for the services like ports, environment variables, or volume. So these things you have to define in your Docker Compose file. What will be your environment of your app? Now, the second step would be run Docker Compose up to start the services. So basically this command reads the docker compose.yml file and spins up all the services as containers, sets up the network, and ensures that they can communicate with each other. And third would be run Docker Compose down to stop and clean up your process. So this is a very basic workflow for the Docker Compose. I hope so you would have got some brief idea regarding this. Now, so let us understand the architecture of our project. So it's a very basic project, guys. In this, we have a backend folder in which I have a server.js. Okay. So if I open this file, so I'm using Express all over here to create something. Suppose what I'm going to do all over here, we will be creating a dashboard, or not a simple dashboard, a simple label where we'll be writing our name. Okay. So here you can see all over here, the port we are using is 4000. Rest, don't focus on these codes, what I have written. You can just ignore this because in this video, we'll be focusing mainly on Docker files. Now, you can see also one thing that we have the package.json. So type cd backend. And after that, just type npmi. So it is going to install all these dependencies. I will share this code all over here with you, the GitHub link. You can copy the repo. Now we have done this. So after this, we will be writing our Docker Compose file. So all over here, you can see the first thing that I'm typing all over here is use node, okay, version 22.3.0. Because if I go to the terminal, okay, first I will cross check what kind of node version I'm using. So just type all over here node. And you can see all over here, it shows 22.3.0. So this is our node version. So what is the significance of this line? Basically, this line sets up the base image for the Docker container. So node 22.3.0 refers to the official Node.js image of version 22.3.0 from the Docker Hub, where it downloads all these node packages. And also, Node Package Manager or NPM will be included in this. Now, the second thing, workdir/app. So basically, this line is setting up the working directory inside our container. So /app is our working directory. Docker container is a place where your application files will be copied. So here in this container, all your application files will be copied in this directory called /app. And then there is a copy. So copy package.json and run npm install. So you can see all over here, we have a package.json file. So all of the dependencies which are present all over here, okay, will be downloaded by Docker. Now copy the backend code. So I have added two dots, copy ... What is the significance of these two things? This command copies all the files from the host machine to the current directory, which is /app. Okay. Now the first dot refers to the current directory, okay, which is on your host machine. And the second directory refers to the destination directory inside the container, which is /app. And finally, we are exporting our port, which is expose 3000. Okay. Now we are running it on cmd node server.js. Okay. So this is our official port that we are using. I hope so you have got a bit idea regarding the backend file. Now let us go to the front end file. So we have three files all over here. So this is our index.html. Okay. This is our script.js where I have written certain script, front end script basically, and here is our CSS file. So don't worry about all these files. You can copy from the link which I'll be sharing in the description box. Now the important file that we have to focus on is this. So if I go all over here, so the same thing from node 22.3.0. So I'm installing node version of this, okay, from Docker Hub. Then I'm creating a working directory all over here. So this will be our working directory where all the code will be copied. Now similarly, the two dots are here. So I have explained you earlier. This is for the host machine. The address from all the codes will be copied to the destination, which is /app directory. Now here, what I'm doing, guys, I'm running run npm install g http server. So what is http server? So basically, this will install the http server package globally. So here, that's why g flag is given, okay, inside the Docker container. So http server is a simple, lightweight http server for serving static files. And here G is installing it globally so that it can be accessible from anywhere within the container. This is necessary because we are using the HTTP server to serve the HTML, CSS and JavaScript file. Then I'm exposing this to port 3001. And finally, I'm serving our CMD HTTP server. Then there is a comma, okay, then P, then 3001. So this basically specifies the default command to run when the container starts. So this will run the HTTP server, okay, on the port 3001, and the P option will allow you to specify which port the server will use. So this was all about the Docker file for the backend. Now we have successfully created a Docker file for our backend and for our frontend. Now let us proceed to the docker compose.yml file. You can see all over here, we have the version, which is 3, okay. Version 3 is specifying the version of Docker Compose file format being used. In this case, the version is 3, which is widely supported and includes the feature like networking and volume. Each Docker Compose version offers different features and syntax. Version 3 is compatible with Docker Swarm mode and also provides a better support for services and scaling. Next, you see the services block, which defines the individual container or services that Docker Compose will create and run. In this file, there are two services, the front end and the back end. And these services are containers that will run in isolated environments but can communicate through Docker network. So you can see the build is front-end, ports we are using 3001. It is depending on the backend, and network is app network. Okay, so they will be communicating on app network. Similarly for backend service, the build is backend, port is 4000. Okay, network is app network. Okay, driver is bridge. Pretty much fine. Now finally we have the network section. So in the networks, it defines a custom Docker network that will allow services to communicate with each other. Docker automatically creates default network for services if none is specified. But here we have the custom network, which is app network. Now, what is driver bridge? This is a network type, which is a kind of a bridge network. This is a default network driver for Docker and provides communication between containers within the same network. Now, how these services will be interacting? So the front-end service, which will serve the static file, the HTML, CSS, and JavaScript on the port 3001. Okay. Now on the backend service, it is most likely to run on port 4000. Okay, so that is one thing that we have built all over here. And this scenario, suppose we are building a typical application. So the front end will be hosted on 3001 and the backend will be hosted on 4000. Now let us build our Docker Compose file. Now in order to run this application, what you have to do, guys, go to your root folder, which is demo. Okay, and type Docker Compose build. Now, after this, what you have to do, guys, just right click all over here and you can see it will start building our application. So it has started building our backend file. Okay, so you can see it has started running. Now it is going to create a container demo backend 1 and demo front end 1. So you can see our container is created. Now it is starting the HTTP server. Okay, now the version we are using, okay, the version we are using is 14.1.1. The CORS is disabled all over here. This is security protocol. There are a lot of other options that is available. So you can see the backend server is running on port 4000 and still is on the process of creating. Now, if we navigate to given port, which is 127.3.0, so which I have already opened. So now let's right click all over here. So you can see our application is completely running on this port. Very basic application. So just click your name, something like say Sham, and right click all over here. So it's a basic application and all the data will be stored on the server. Okay. So the main agenda of this project was how we created two services, which was front-end service and the back-end service. And finally, we merged the both services with the help of Docker Compose file. So two separate Docker containers, and with the help of Docker Compose file, we are able to run this. So this was a very basic introduction to Docker Compose. I hope so. You would have got a brief idea regarding what Docker Compose does and why it is so much popular tool in today's software development methodology. Now, every job in today's scenario requires you to understand the Docker, Kubernetes, and all these important DevOps tools.
Hello, and in this video we're going to cover a common conversation, which is Kubernetes versus Docker. But before we jump into that, I want you to hit the subscribe button so you get notified about new content as it gets made available. And if you hit the notification button, that notification will then pop up on your desktop as a video is published from Simplilearn. In addition, if you have any questions on the topic, please post them in the comments below. We read them and we do reply to them as often as we can. So with that said, let's jump into Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker, and we can actually go through and understand what the problems specific companies have actually had and how they're able to use the two different tools to solve them. So our first one is with Bose, and Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing two primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the number one container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it, and you should be able to look and see whether or not you can add your own company to this list. So let's dig into the final area, which is the actual Kubernetes architecture. I'm going to cover this at a high level. There's actually another video that you can that Simplilearn has developed, which digs deeper into the Kubernetes architecture. And so the Kubernetes architecture is a cluster-based architecture, and it's really about two key areas. You have the Kubernetes master, which actually controls all of the activities within your entire Kubernetes infrastructure. And then you have nodes that actually are running on Linux machines that are controlled by the master. So let's kind of go through some of these areas. So if we look at the Kubernetes master to begin with, we'll start with etc. This is a tool that allows for the configuration of information and the management of nodes within your cluster. And one of the key features that you'll find with all of the tools that are managed within either the master environment or within a node is that they are all accessible via the API server. And what's interesting about the API server is that it's a RESTful based infrastructure, which means that you can actually secure each connection with SSL and other security models to ensure that your entire infrastructure and the communication going back and forth across your infrastructure is tightly secured. Scheduler goes ahead and actually, as you'd expect, it actually manages the schedule of activities within the actual cluster. And then you have the controller, and the controller is a daemon server that actually manages and pushes out the instructions to all of your nodes. So the other tools really are the infrastructure, and you can consider them the administration side of the master, whereas controller is the management. It actually pushes out all of the controls via the API server. So let's actually dig into one of the actual nodes themselves, and there are three key areas of the nodes. One is the Docker environment, which actually helps and manage and maintain the container that's actually inside of the node. And then you have the kubelet, which is responsible for information that goes back and forth, and it's going to do most of the conversation with the API server on the actual health of that node. And then you have the actual Kubernetes proxy, which actually runs the services actually inside of the node. So as you see, all of these infrastructures are extremely lightweight and designed to be very efficient and very available for your infrastructure. And so here's a quick recap of the different tools that are available, and it really breaks down into two key areas. You have your Kubernetes master and the Kubernetes node. The Kubernetes master has the instructions of what's going to happen within your Kubernetes infrastructure, and then it's going to push out those instructions to an indefinite number of nodes that will allow you to be able to scale up and scale down your solution in a dynamic way.
Kubernetes is an open source platform used for deployment and management of containers. So, let's get started. Now, the first step is to install the necessary dependencies using two of the commands. First is sudo apt get update, which gets all the updates. And then you have to enter password. So this will take a few seconds. That's done. The next step is to install apt transport HTTPS. This is basically used to make repositories via HTTPS. So let's go ahead with that. Sudo. Okay, that's done. Going ahead, the next thing we have to do is to install the Docker dependency using the command sudo apt install docker.io. You have to choose Y, and this will take a few minutes. Okay, that's done. So after installing the Docker, we have to start and enable the Docker using the command sudo systemctl start docker and sudo systemctl enable docker. So now the Docker is enabled. So now we are done with the first step of installation. The next step is we have to install the necessary components for Kubernetes. Before that, we have to install the curl command because curl command is used to send data using a URL syntax. Let's install the curl command using the command sudo apt-get install curl. So you have to select Y and this will take few minutes. So moving on, the next step we have to do is download and add key for Kubernetes installation from a URL. So let's go ahead with that. Sudo curl. So this is where we get the key and then we have to add it using sudo apt key add. And it's done. So the next step is we have to add a repository in a certain location. So before doing that, we have to change the permission of that file. So we do that using sudo chmod command. Okay, so the permission is changed. Now let's go ahead and save this file in that location. First, we have to enter this command into the file. This is a URL. Save as. So we have to save it in this location. Let's rename this to Kubernetes.list. Now let's see. Okay, so here it is. Now moving forward. Now we have to check for any updates available. In the next command, we are going to install the Kubernetes components, that is kubelet, kubeadm, kubectl and Kubernetes CNI. So let's go ahead with that. So this is going to take a few minutes. Now that's done. So the next step, we have to initialize the master node, and to do this we have to first use a swap off command to disable the swapping on other devices. So let's do that. Sudo swap off -a. Now let's go ahead with the initialization. Sudo kubeadm init. This is going to take a few minutes. Okay, so before going to the next step, to start the cluster, we have to use these three commands. Let's just copy paste it. Okay, that's done. So, moving forward, the next step is to deploy pods using the following command. Now the pods have been deployed to our network. To see all the pods, you have to use the command sudo kubectl get pods. There you can see the pods that have been deployed.
So we're going to break out the presentation into the following areas. We're going to cover what Kubernetes is and why you want to be using it. We're going to introduce the actual architecture and provide an overview of how it contains the containers and the other components that you'd have within the architecture. We'll also compare Kubernetes with Docker Swarm, and one of the things that you hear with Kubernetes almost in the same breath is Docker. We have to be careful not to confuse Docker from a container point of view and Docker Swarm, which is a container management tool. And Kubernetes is also a container management tool, so we'll compare the two of those. And then we'll look at the hardware and software components, and then finally do a deep dive into the architecture of Kubernetes and provide a case study of where Kubernetes has been used successfully in the past. So let's jump into this. So what actually is Kubernetes? So Kubernetes is a tool that was designed to actually help manage and contain large groups of containers. It was developed originally by Google out of the Google Borg solution, and then open sourced by Google. The actual environment allows you to manage large groups of containers. So if you're a developer in DevOps and you're working with Docker, then you're used to the concept of a container. And you'll also know that containers and cloud technologies tend to be almost breathed in the same breath. So the work that you're doing with Kubernetes is to be able to manage large groups of containers inside of the cloud. The thing that's great about working with Kubernetes is that it is incredibly flexible and it allows you to have incredibly complex applications run efficiently. So let's step into why you'd want to use Kubernetes. So a couple of key points. Kubernetes itself is an open source solution originally developed by Google, but it is available on most cloud platforms today. So AWS, Google Cloud, Microsoft Azure, all of them support Kubernetes. And what you'll find is as you're setting up your infrastructure, particularly if you're using containers, you'll see that the support for Kubernetes is floated up very, very efficiently and effectively by all three vendors. It's extremely useful for being able to manage large modular environments, and that's really kind of the, I think one of the big benefits of Kubernetes is its modularity, is that it really breaks down containers into their smaller parts. And once you do that, it becomes much more efficient for you as an administrator to be able to manage that entire environment. The reproducibility of Kubernetes is extremely high. You can build out infrastructures very quickly and have them being able to manage and have containers coming on and off and killed and created to be able to help load balance your entire environment. And so again, we keep talking about containers, but that's really what Kubernetes is all about, is being able to manage your applications that are managed through containers and being able to do that in a virtualized infrastructure. And the thing that's also really good with Kubernetes is it's really easy to deploy solutions. You just have to use a simple curl call and you can actually push out your Kubernetes infrastructure. So let's have an overview of the Kubernetes architecture. So Kubernetes is really broken up into three key areas. So you have your workstation where you develop your commands and you push out those commands to your master, and the master is comprised of 4 key areas which essentially control all of your nodes, and the node contains multiple pods, and each pod has your Docker container built into it. So consider that you could have really almost an infinite number of infinite number of nodes being managed by the master environment. So you have your cluster, which is a collection of servers that maintain the availability and the compute power, such as RAM, CPU, and disk utilization. You have the master, which is really components that control and schedule the activities of your network. And then you have the node, which actually hosts the actual Docker virtual machine itself and be able to actually control and communicate back to the master the health of that pod. And we'll get into more detail on the architecture later in the presentation. So you keep hearing me talk about containers, but they really are the center of the work that you're doing with Kubernetes. And the concept around Kubernetes and containers is really just a natural evolution of where we've been with internet and digital technologies over the last 10-15 years. So before Kubernetes, you had tools where you're either running virtual machines or you're running data centers that had to maintain and manage and notify you of any interruptions in your network. Kubernetes is the tool that actually comes in and helps address those interruptions and manages them for you. So the solution to this is the use of containers. So you can think of containers as that natural evolution from 15, 20 years ago. You would have written your code and posted it to a data center. More recently, you probably posted your code to a virtual machine and then moved the virtual machine. Now you actually just work directly into a container, and everything is self-contained and can be pushed out to your environment. The thing that's great about containers, they're isolated environments, very easy for developers to work in them, but it's also really easy for operations teams to be able to move a container into production. So let's kind of step back and look at a competing product to Kubernetes, which is Docker Swarm. Now, one of the things that we have to remember is that Docker containers, which are extremely popular, are built by the company Docker and made open source. And Docker actually has other products. One of those other products is Docker Swarm. And Docker Swarm is a tool that allows you to be able to manage multiple containers. So if we look at some of the benefits of using Docker Swarm versus Kubernetes, one of the things that you'll find is that both tools have strengths and weaknesses. But it's really good that they're both out there because it helps it really kind of justifies the importance of having these kind of tools. So Kubernetes was designed originally from the ground up to be auto-scaling, whereas Docker Swarm isn't. The load balancing is automatic on Docker Swarm, whereas with Kubernetes you have to manually configure load balancing across your nodes. The installation for Docker Swarm is really fast and easy. I mean, you can be up and running within minutes. Kubernetes takes a little bit more time, is a little bit more complicated. Eventually you'll get there. I mean, it's not like it's going to take you days and weeks, but it is a tool that's, when you compare the two, Docker Swarm is much easier to get up and running. Now, what's interesting is that Kubernetes is incredibly scalable, and that's its real strength, is its ability to have strong clusters. Whereas with Docker Swarm, its cluster strength isn't as strong when compared to Kubernetes. Now, you compare it to anything else on the market, it's really good. So this is kind of a splitting hairs kind of comparison, but Kubernetes really does have the advantage here if you're looking at the two compared to each other for scalability. I mean, Kubernetes was designed by Google to scale up and support Google Cloud network infrastructure. They both allow you to be able to share storage volumes. With Docker, you can actually do it with any container that is managed by the Docker Swarm, whereas with Kubernetes, it manages the storage with the pods, and a pod can have multiple containers within it, but you can't take it down to the level of the container. Interestingly, Kubernetes does have a graphical user interface for being able to control and manage the environment. The reality, however, is that you're likely to be using terminal to actually make the controls and commands to control your either Docker Swarm or Kubernetes environment. It's great that it has a GUI to get you started, but once you're up and running, you're going to be using terminal window for those fast, quick administrative controls that you need to make. So let's look at the hardware components for Kubernetes. So what's interesting is that Kubernetes is extremely light. Of all the systems that we're looking at, it's extremely lightweight. It allows you to have, if you compare it to like a virtual machine, which is very heavy, Kubernetes is extremely lightweight and hardly uses any resources at all. Interesting enough, though, is that if you are looking at the usage of CPU, it's better to actually take it for the cluster as a whole rather than individual nodes, because the nodes will actually combine together to give you that whole compute power. Again, this is why Kubernetes works really well in the cloud, where you can do that kind of activity rather than if you're running in your own data center. So you can have persistent volumes such as a local SSD, or you can actually attach to a cloud data storage. Again, Kubernetes is really designed for the cloud. I would encourage you to use cloud storage wherever possible rather than relying on physical storage. The reason being is that if you connect to cloud storage and you need to flex your storage, the cloud will do that for you. I mean, that's just an inherent part of why you'd have cloud storage. Whereas if you're connecting to physical storage, you're always restricted to the limitations of the physical hardware. So let's kind of pivot and look at the software components as compared to the hardware components. So the main part of the components is the actual container, and all of the software running in the container runs on Linux. So if you have Docker installed as a developer on your machine, it's actually running inside of Linux. That's what makes it so lightweight. And really, one of the things that you'll find is that most data centers and cloud providers now are running predominantly on Linux. Inside of the container itself is then managed inside of a pod, and a pod is really just a group of containers bundled together. And the Kubernetes scheduler and proxy server will then actually manage how the pods are actually pushed out into your Kubernetes environment. The pods themselves can actually then share resources for both networking and storage. So pods aren't pushed out manually. They're actually managed through a layer of abstraction part of their deployment. And this is the strength of Kubernetes. You define your infrastructure, and then Kubernetes will then manage it for you. And there isn't that problem of manual management of pods if you have to manage the deployment of them. That's simply taken away, and it's completely automated. And the final area of software services is on Ingress, and this is really the the secure way of being able to have communication from outside of the cluster and passing of information into that cluster. And again, this is done securely through SSL layers, and allows you to ensure that security is at the center of the work that you have within your Kubernetes environment. So let's dive now into the actual architecture before we start looking at a use case of how Kubernetes is being employed. So Kubernetes, again, is we looked at this diagram at the beginning of the presentation, and there are really three key areas. There's the workstation where you develop your commands, and then you have your master environment, which controls the scheduling, the communication, and the actual commands that you have created, and pushes those out and manages the health of your entire node network. And each node has various pods. So we break this down. So the master node is the most vital component. With the master, you have four key controls. You have etc., controller manager, scheduler, and API server. The cluster store, etc., this actually manages the details and values that you've developed on your local workstation, and then we'll work with the controller, schedule, and API server to communicate that out, those instructions of how your infrastructure should look like to your entire network. The control manager is really an API server, and again, this is all about security. So we use RESTful APIs, which can be packaged in SSL to communicate back and forth across your pods and the master, and indeed the services within each of them as well. So at every single layer of abstraction, the communication is secure. The schedule, as the name would imply, really schedules when tasks get sent out to the actual nodes themselves. The nodes themselves are dumb nodes. They just have the applications running on them. The master and the is really doing all of the work to make sure that your entire network is running efficiently. And then you have the API server, which has your REST commands and the communication back and forth across your network that is secure and efficient. So your node environment is where all the work that you do with your containers gets pushed out to. So a work is really it's a combination of containers, and each container will then logically run together on that node. So you'd have a collection of containers on a node that all make logical sense to have together. Within each node, you have Docker, and this is your isolated environment for running your container. You have your kubelet, which is a service for conveying information back and forth to the service about the actual health of the Kubernetes node itself. And then finally, you have the proxy server, and the proxy server is able to manage the nodes, the volumes, the creation of new containers, and actually helps pass the health of the container back up to the master to see whether or not the containers should be either killed, stop started, or updated. So finally, let's look at see where Kubernetes is being used by other companies. So Kubernetes is being used by a lot of companies, and they're really using it to help manage complex existing systems so that they can have greater performance, and with the end goal of being able to delight the customer, increase value to the customer, and hence increase value and revenue into the organization. So an example of this is a company called BlackRock, where they actually went through the process of implementing Kubernetes. So BlackRock had a challenge where they needed to be able to have much more dynamic access to their resources. They were running complex installations on people's desktops, and it was just really, really difficult to be able to manage their entire infrastructure. So they actually then pivoted to using Kubernetes, and this allowed them to be able to be much more scalable and expansive in the management of their infrastructure. And as you can imagine, Kubernetes was then hooked into their entire existing system and has really become a key part of the success that BlackRock is now experiencing of a very stable infrastructure. And the bottom line is that BlackRock is now able to have confidence in their infrastructure and be able to give that confidence as back to their customers through the implementation and more rapid deployment of additional features and services.
On that note, if you are looking to learn Kubernetes, then get certified in DevOps with postgraduate program in DevOps by Simplilearn. This program offers blended learning that combines live online DevOps certification classes with interactive labs that gives you hands-on experience. You will gain expertise in tools like Terraform, Kubernetes, Maven, Ansible, Jenkins, Docker, JUnit, Git, and more. We prefer 1 year of prior experience to enroll in this course. So why wait? Enroll the course from the link in the description box.
So what are orchestration tools? The application development and the lifecycle management from the time the application is developed, connecting the source code to your continuous integration, to testing them all along your development process, and eventually moving it down to production, managing your production servers, the dependencies that your software has, the requirement that it has in terms of the hardware, the features of fault tolerance, self-healing capabilities, auto-scaling, all this has complicated over the last few years. As a part of DevOps, one thing that everyone is interested in is managing all this application dependency or lifecycle management using some or the other kind of a tool. So that's where these orchestration tools have become very, very popular. So what kind of features that they provide is you'll have to just let them know what are the kinds of tool sets that is required, what are the fault tolerance mechanisms that it has to be adopted to, what kind of a self-healing capabilities that application will have to need, and if at all there is any auto-scaling features that is required. If at all you can bake in all these specific parameters into your tool, your orchestration tool becomes a one-stop shop for all your deployment and configuration management needs. That's where these orchestration tools have become a very, very popular and relevant, specifically these days when people are more and more interested in adopting DevOps practices. Alright, so having said that about orchestration tools, let's concentrate on two of these orchestration tools specifically for container management: Docker, Swarm, and Kubernetes. Many of the applications that are written for these kind of containers are called or kind of fall into a category of cloud native, where the application need not know much about the underlying infrastructure or the platform where these applications are running. So these two, along with Apache Mesos, there are many other container management systems, but I'm going to pick Docker, Swarm, and Kubernetes for comparing the features that is provided by these two frameworks. For the sake of comparison, I picked up Docker Swarm and Kubernetes just because of the reason that both of them operate in the space of container management. They do something very, very similar to containers. That's the similarity that exists between these two orchestration tools. However, there's a big difference that exists when it comes to the types of containers that both of them cater to, and also the capacity of workloads they can be used for. Docker Swarm is a cluster management solution that is provided by Docker Container. Docker is one of the very, very popular containers of recent times, and in case you have your applications that is totally powered by only Docker containers, if you have a need where you want to run a cluster of servers which are running only Docker containers, Docker Swarm should be your choice for your orchestration tool. Kubernetes, on the other hand, can cater to any other types of containers other than Docker, and including Docker as well. So in case you have your applications which have got Docker in them, which have got RKT in them, which they have got LX in them, or any other type of container, Kubernetes should be your choice of orchestration tool. A Docker Swarm can manage up to 40, 50 or 60 max nodes. So in case your application is totally written in Docker containers and the load or the expected cluster size is about 50-60 nodes, Docker Swarm should be your choice of orchestration tool. On the other hand, Kubernetes is something that was open sourced by Google, and the scale of operations that Kubernetes can cater to is Google scale. So if in case your applications are more than 1,000 nodes, that is where Kubernetes comes into play. That's the big difference that exists between Docker Swarm and Kubernetes. Putting those differences aside, let me compare Docker Swarm and Kubernetes based upon other features which are similar in nature. The first and important feature that Kubernetes provides is something called as auto-scaling. If at all the load on your cluster is too high and your application is experiencing more load, so Kubernetes can add new nodes to your cluster. Of course, you'll have to configure Kubernetes in order to have those capabilities where it can spin up new VMs or new nodes. If at all you do that configuration correctly, Kubernetes has got the capacity, or it has got the feature where it can bring up a new node and add it to the cluster on the fly based upon the load that exists at that moment. On similar lines, if at all the load is not too high, it can identify a few of those nodes which have got less number of replicas or less number of application containers running on it. It can move them to some other node and also scale down by deleting few nodes from your cluster. So that is the powerfulness of auto scaling which is provided by Kubernetes, and this unfortunately does not exist in Docker Swarm. The other feature of load balancing, specifically application load balancing. So Docker Swarm gives you an application level auto load balancing. However, Kubernetes gives you the flexibility of manually configuring any other type of load balancer of your choice for application load balancing. Installation. As I mentioned earlier, Docker Swarm is a loose cluster of containers which are running on nodes. It is very easy to spin up a new node and then connect them to a swarm. And this can be done in a very loosely coupled way where you can create swarms of your choice. Nodes are allowed to connect to swarms and quit or leave the swarms on the fly. So in and all, the installation is pretty easy and fast. Kubernetes, on the other hand, the configuration of Kubernetes, the way to spin up a big cluster specifying the size of the node, how many master nodes, how many config planes that you want, how many nodes that you want. It's a pretty tough thing to bring up a Kubernetes. Scalability. Kubernetes strength is very strong. They are very tightly coupled, and even they have the capability where on the cluster size things or the nodes can be increased on the fly based upon the requirement. On a Docker Swarm, the cluster strength is weak as compared to Kubernetes. Worker nodes can be added to a swarm. Worker nodes can be asked to leave a swarm or can be taken out of a swarm based upon the requirement. So this is kind of a loosely coupled architecture for Docker Swarm, while Kubernetes, the cluster is very tightly coupled. Since Docker Swarm runs only Docker containers, containers find it very easy to share data and a lot of other things with each other because they all have the same signature. They are all from the same family. So it's very easy for them to share not just volumes, but a lot of other things. However, for Kubernetes, since it manages containers of different types, if your application has to share some data across different containers, there's a little bit of a complexity in how you would want your containers to share data. Also, when it comes to Kubernetes, Kubernetes groups containers in something called as pods. While a pod can have either one container, that's the preferred choice, or multiple containers. And the idea of pod is like each pod can run in any other node. It's not guaranteed that you would want to have 2 or 3 pods to be running on the same node. That makes data sharing a little bit of a different thing compared to Docker Swarm. GUI. So there's not a good enough UI tool in Docker Swarm, at least the CE edition of it, which will allow you to get to know what is running on your containers, what is the size of the containers, what is the volume of the containers, and all that stuff. There are some free and open source tools like Portainer, which gives you a good visibility into your running Docker containers. However, there's nothing at a swarm level that is provided by Docker. Kubernetes gives you an out-of-the-box dashboard, which is easy to configure and set up. You can also club it with some metrics services, and you can also get information about the size of the cluster that is running, what is the load on the nodes, and stuff like that. All this across your cluster in a very beautiful dashboard perspective. So that way, this is a little bit of a good UI for Kubernetes, while for Docker Swarm, there isn't anything that is provided out of the box. Let me spend some time in explaining a little bit about the Kubernetes architecture, what comprises of the Kubernetes cluster, what resides in a master or a control plane, and what resides in a worker node. This is a very high level depiction of a Kubernetes cluster. So this is the master node, which has got something called as a cluster store, a controller, a scheduler component, and an API server. And these are the bunch of nodes that are connected are administered by the master node. The master node can be 1, 3, 5, typically an odd number. This is as per the typical cluster management thing where you would need the master nodes to be in odd numbers so that whenever there's any contention in terms of what needs to be deployed where or where to give the job to whom and stuff like that, all the masters would cast their vote and they would decide on the outcome. So that's the master node, and there are a bunch of nodes which can be connected and administered by the master node. kubectl, or the command from using which anybody can assign some workloads to the cluster, can also be run either on the same node or on a separate node. So kubectl is the command line tool that we will be installing and using in order to fire up our commands to our cluster. So if at all I have to put up a job on our cluster, if I have to give out any specific commands to my cluster, all this is done using kubectl. There's a bunch of REST APIs which is used by kubectl, and kubectl will talk to the API server and fire up the commands specific to my cluster. What runs in the master node? Master node, without saying, it's the most important component of any of the cluster. If at all you're running cluster with only one master node, if your master node goes down, there's no other way that you can, or any user can talk to the different nodes in the cluster. So master node is the most vital component responsible for the complete Kubernetes cluster. There's always one node that should be running as a master node. That's the bare minimal requirement for your cluster. So what are the other components in the master node? The most important one is called etcd. So this is nothing but a data store, a value of key value pair which is stored, which contains all information about your cluster. So all the configuration details, which node is up, which worker node is down, all this information is stored in the cluster store. So all the managers would access this cluster store before they go ahead and decide any other work item or anything else that has to be done specific to your cluster. What's in the controller? As the name says, controller is something, it's like a daemon server that is running in a continuous loop. All the time it is responsible for controlling the set of replicas, the kind of workloads that is running based upon the configuration that the user has set in. So if at all, if you are aware of something called as replication controllers, endpoint controllers, namespace controllers, all these controllers are managed by the controller component. If any user asked for some 3 replicas of a particular pod or a service to be running, and if at all any of the nodes goes down or the pod goes down for whatever reason, the controller is the one who wakes up and assigns this particular job or the pod to some other available node by looking up for the details using in the cluster store. That's the importance of the control manager or the controller. The scheduler assigns the tasks based upon whoever is asked for any job to be scheduled based upon a time frame or based upon some criteria. It also tracks the working load as to what exactly is the load, who is running what in the cluster, and places the workload on whoever is the available resource at that time. Alright, API server. This is one other important component in our Kubernetes cluster, where how would the end user deploy or give out any sort of a workload onto your cluster? All the requests come to the API server. So this is an entry point for all your requests that come into your cluster. Anybody wants to deploy something, anybody wants to scale up a controller, anybody wants to bring down few services, anybody wants to put in a service, all this will have to come in as a part of a REST API endpoint. And API server is the entry point. In case you don't want somebody to access your cluster, in case you want only specific people or specific users to be running some specific workloads, you can set all those role-based access control for this API server. So this is the entry point for anyone who wants to submit any job to your cluster. So that's a quick overview about the master node. What are the important components of a master node? Now let's go over to what runs in a worker or a slave node. As I mentioned earlier, slave nodes are something where the job that is submitted to your cluster is eventually run as a pod, as a service, as a container. So in Kubernetes world, there is something called as a pod. A pod is nothing but a combination of a container. It is a wrapper around your running containers. So slave nodes or the worker nodes typically run these pods. So that is where the whole workload typically gets run. But there are a bunch of other components in the node which also manages what runs in the pod, who has to have access to the pod, what is the state of the pod, is it in a running state, is it going down for some reason, and all the stuff. So let's quickly go over those components that is there in the slave node. The most important component, in my opinion, that should be on the node should be the container runtime. As I mentioned earlier, Kubernetes can run any different types of containers, not just Docker. So in case you want to have a node which wants to have Docker running on it, RKT running on it, LKC running on it, or any other container environment that is running on it, you have to ensure that the specific container runtime environment is available on that specific node, so that whenever a job is submitted, a description of what needs to be run as a part of the pod, what should be the image with which it should be powered, and what kind of a container to spin up. So that's what, when the job is finally assigned to this particular node, it would definitely need a container runtime to be up and running. So that exists only if at all the container runtime is installed and running on your Kubernetes worker node. Okay, now that we know what our Kubernetes node can run, how would somebody assign a job to our node? That is using something called as a kubelet. As the name says, kubelet is a small subset which talks to the kube API server. So any node which has to run any kind of a pod, all these instructions are passed around by the kube API server to the kubelet. And kubelet is capable of processing whatever job that is assigned to it and ensuring that so many pods and so many services are spun up based upon the requirement. The last component that exists in the worker node is the kube proxy or Kubernetes proxy. This plays a very, very important role, acting as a load balancer and a network proxy. So what typically happens is whenever the pods are running in nodes, the pods can be typically running in any node. There is no affinity towards any node on which these pods are running, because pods or containers are something called as ephemeral. They can run anywhere. So how would somebody reach out to these applications that is running in some pod which is running in one container now and running in probably another container, another node altogether tomorrow? So that is where your Kubernetes proxy comes into picture, and this component will ensure that any container that is spun up or any pod that is spun up, it keeps track of all these pods and kind of connects the endpoints or acts like a DNS server, so that it knows when somebody is trying to reach out to this particular service, which is the pod on which the service is typically running. So that plays a very, very important role by acting as a load balancer and a network proxy. Now that at a very high level we know what are all the components that make up of our Kubernetes cluster, let's go ahead and create a small cluster. We'll spin up this cluster on AWS platform. Finally, we get to the demo section of my tutorial. Now that you guys are aware as to what is Kubernetes, what is the use of Kubernetes, you also know at a very, very high level what are the components of a cluster. What is a master node or a control plane? What are the components of a master node, and what should be existing in a worker node? You're probably thinking that it's going to be pretty hard to kind of set this up. So let me demystify that by running you with a quick demo of how to set up a simple 3-node Kubernetes cluster using a tool called kops. And I will be doing this whole setup on my AWS cloud. Okay, so what is kops? Kops is nothing but a simple tool. This is an admin tool that allows you to bring up production grade Kubernetes environments. As I said, setting up a Kubernetes cluster on a bare metal is a little challenging. So that is why I would use something called as a kops, and I will use this on my cluster, which I will spin up on my AWS instance. So I have an AWS account, and what I will do first is I will first spin up an EC2 server. I will power this with one of the Linux AMIs, and I will install kops on it. Now this will be my starting point from where I'm going to trigger running up a big cluster. In our case, I'll try to keep it a little small. I don't want too many nodes in my cluster. I'm going to have one master node and 2 worker nodes. This whole operation would be done programmatically by installing this kops admin tool. So as you may know, AWS, it's a little hard for me to programmatically run other components or rather bring up servers. It's not pretty simple. So what I would do is I will create an IAM role which will attach to my EC2 server, so that my EC2 server gets powered with all the required role, so that it can go ahead and spin up cluster based upon my configuration that I'm going to specify. Alright, so once I have my cluster set up, I will also install kubectl, which you would probably know by now is nothing but a command line utility using which I can kind of connect to my cluster, give out some jobs, put some pods and stuff like that. So I will use kubectl. I will also have a pair of SSH keys so that from this machine, I would be able to successfully get onto the master node and submit jobs on my behalf. So let me begin by first logging into my AWS account. All the steps that I will be following to bring up my AWS cluster, Kubernetes cluster, will be documented, and I'll be sharing you this document in a GitHub repository so that in case anybody wants to try, you'll be more than happy to find all the required instructions in one place. Okay, now the first thing that I would need is to launch an AWS EC2 instance. Now this is an instance where I'm going to install kops, and I will use it as a base server from where I'm going to fire some commands which will bring up my Kubernetes cluster. So let me log into my AWS account, and let me stick to one particular region, and let me bring up one EC2 instance. Alright, so let me launch my instance. Let me choose, doesn't matter either ways, but in case you want to try it on your free tier, I would recommend choose free tier only and choose an AMI of your choice. Let me choose this instance. I will make it T2 micro. That is good for me. Configuration, instance details. All right. I don't want to change anything here. That looks good. Maybe I will change this 30 gig. That's good for me. Let me add a tag to my instance. I will name this as my kops server. Alright, I would need a bunch of ports to be opened up. So what I will do is I will create a new security group called open to the word. I would not recommend that you do this since I don't want to, it will take a long time for me to specifically pick and choose the ports that has to be open for running my cluster. I don't want to do that. I will open up all the HTTP and HTTPS ports so that it's quicker. So I will say all TCP. I would say from anywhere, just to be on the safer side. I also open HTTP and HTTPS, and I will make this anywhere and anywhere. This is good for me. I will say review and launch. Alright, so I chose a T2 micro instance. Just for the sake of easiness, I've opened up all the ports, and the instance details are, you've seen what is that I've chosen. Alright, now important part is like I would need a key pair. I need to create a new key pair. I will call this as Simplilearn keys. I will download this key pair, and then I will launch the instance. It will take some time for my EC2 instance to come up. In the meanwhile, what I'll do is I will convert. I have this PEM file, which is the pair of keys, the SSH keys with which I need to log into my EC2 instance. So I'll need to convert this because I'm trying to connect from my Windows box. I would need to convert this into a PPK file. So I have puttigen. I'm going to load my set of keys here and convert that key into a PPK key. All right, open. All right, I would say save. Hang on, save private key. Yes, I would say Simplilearn or Simplilearn private key. I'll save this here. Done that. That's all. So this is my public key, which is the PEM file, and this is my PPK or my private key. Now using the private key, I will log into my EC2 instance. Okay, now my EC2 instance is up and running. It is running in this Ohio region, and this is the IP address of my public IP address of my machine. So let me connect to it. So I use MOBA Xterm, which is nothing but an SSH emulator. You can use PuTTY or any of these sessions which allow you to do an SSH. This is my IP address of my machine, and since I've spun up an Amazon AMI, this is the default user. I would need to specify the private keys for my session, and this is the private key for my session. Say OK. I am in my Amazon EC2 instance. So let me look at what are the other things that I need to do. Alright, so as I said, I just brought up my EC2 instance, but I would need my EC2 instance to run few things on my behalf so that it can spin up other EC2 instances. It can also talk to an S3 bucket where I'm going to store the instance state of my Kubernetes cluster. Also some sort of an auto scaling group because I want to spin up more and more instances. I also want to have a private hosted zone using my Route 53. So I would need my EC2 instance to have all these sort of permissions for my server. So what I would do is I will go and create a permission a role in the EC2, or rather in the AWS IAM role, and I will attach this IAM role to my EC2 instance. All right, so let me go to my IAM, which is nothing but the identity and access management. I will create a role called as possibly COPS role. I will create a role. This role will be used by my EC2. So I'm going to click on EC2. I will say next permissions. They would need a lot of permissions, specific permissions to be very honest. And the permissions are all listed out here, S3, EC2 and all this stuff. Just to keep it pretty simple, what I would do is I will create a role with the administrative access. All right, so I don't want any tags. I'm going to review. I'll create a role name. I will say COPS role for EC2. All right, so I'm going to create a role which has got administrative access roles. I'm going to create a role. So this would ensure that my EC2 instance from which I'm going to run my cluster would have all the prerequisite permissions so that it can go and spin up instances, talk to S3 buckets and all that stuff. All right, now let us have our running instance get powered by this role. So I will connect this role to my running instance. All right, so this is my EC2 instance that is running. I will say action, attach, replace IAM roles. So there is no role as of now. I would want my COPS role for EC2. This is the role that I created. So I want this new role to be assigned to my EC2. All right, great. Now my EC2 instance, which is my COPS server, has got all the required permissions so that he can create a cluster on my behalf. Great. Now before this, let me do a sudo yum update -y. So that any of the, because this is a newly provisioned VM, I just want to ensure that all my system libraries are all updated. So that when I do install COP and kubectl and all those things, none of them will fail because of some dependency or package issues. So I'm just running a sudo update -y so that all the libraries are updated. Okay, looks like it is done. So let me go ahead and install COPS. COPS is a pretty simple installation. It is available in a particular location. I have to just copy this and ensure that I do a curl and I install this particular stuff. All right, so it is fetching the COPS tool. It's installing for me. Once it is copied down, let me change the mode so that I can execute it, and then also let me move it to my user local bin so that it is available for me in my path. Okay, that's pretty much the COPS installation. Let me also do one other thing. Let me install something called as kubectl. So this is what would be, a tool using which I'm going to be firing my commands to my Kubernetes cluster once it comes up. Right, this is a pretty smaller executable. So kubectl. All right, so I have kubectl as well as COPS installed on my EC2 server now. Okay, now what I'll do next is I'm going to create an S3 bucket in AWS so that the Kubernetes cluster state is persisted in this bucket. So let me create a simple bucket with this name, S3 bucket with this name. So let me go to S3 and let me create a simple bucket with this name. I will just say create a bucket. Okay, so the Simplilearn.Kubernetes is the bucket that I created. So this bucket will store all information about my cluster. Let me now go and create a DNS entry or a DNS zone or a AWS Route 53 hosted zone for my cluster. So this is required so that I can give a cluster name for my Kubernetes cluster that I'm coming up. So I will create a private hosted zone and possibly I will call this as Simplilearn.in. So this will be my name of my private hosted zone. In case you already have any other public hosted zones in your name, you can always put a Route 53 hosted zone specific for your domain name. Since I don't have anyone, I'm just going to create a simple private hosted zone. So let me head down to Route 53, click on any of these and you'll get these hosted zones out here. So I'm going to create a hosted zone here. I'm going to create a hosted zone. Click on create hosted zone. This would be Simplilearn.in. I want to create a public. No, I don't want a public. I want a private hosted zone, and I'm going to associate my VPC ID for this hosted zone. Since I'm going to try out all my exercises in the Ohio region, I will associate the VPC of the Ohio region for this. All right, so this is the one that is specific to the Ohio region. So I will say this one. I'll say create a hosted zone. Great. Now let me come back to my EC2 box. My EC2 is all powered with whatever it needs in order to go ahead with the installation of my cluster. Only few things that I need to take care of is that, now that I put a name for my cluster, I also have an S3 bucket that I've configured for my cluster. I will have to ensure that I need to put in these two configurations as a part of my cluster building activity. So I will open my bash rc file and I'm going to export these two variables. If at all you remember well, these two variables are nothing but the cluster name, which is nothing but the the private hosted zone that I created, and the S3 bucket where I'm going to create, or rather I'm going to store my cluster state. So let me copy these two and open up my bash rc file. All right, so I will just add these two and copy these and export them out as my variable. I'm going to save this here. Now let me ensure that this gets picked up. All right, I've got these two that I've configured, and I've also ensured that these environment variables are set. Now let me create a pair of SSH keys. This is to ensure that I can log into the box that I'm going to be provisioning as a part of my cluster. SSH-keygen. I don't want to give any parameters. Let it go to the home directory with the default name and without any passphrase. All right, so I created a bunch of my key pair. Now I'm all set to go ahead and run my kops. Now kops will ensure that this will take some time for the cluster to come up, but this is exactly how I would define my kops command. I already got it copied here. So kops create cluster. The state of the cluster will be stored in this particular variable, which is what I have exported out. The number of node count is 2. Node count is the worker node count. If at all I don't specify, there's a configuration for specifying the master or the control plane as well. If I don't specify that, the default one is 1. So I'm going to create one primary or the master node and two worker nodes. Size of my master, node size of the worker nodes, what are the zones where I want this to be created, and where do I store the cluster information. And okay, I've already added this master count. This is actually not required, but this is the command that I'm going to fire off so that I bring up my cluster. All right, that went off very fast, but this actually did not create a cluster. It is just the definition of a cluster, and that's why this came out very fast. Now that everything looks good with whatever configuration that I specified, now let me go ahead and create the cluster by saying kops update cluster -a. Yes. Now this will take some time, a good 5 to 10 minutes for it to, because this will actually start provisioning the servers. And as I mentioned earlier, based upon my configuration, I'm going to come up with one master server and two nodes, or the worker nodes. All right, so this is the command for me to validate the cluster, and I'm going to try it out first. I'm pretty sure that it will fail because all my servers are not up yet. It is taking some time. The validation, everything failed. But let me try to look at my EC2 instances and see how many servers do I have running as of now. If you see, I had only one server that I had started, which was my cop server, and automatically the other three instances, one is called nodes.simply.in. These two are the nodes, and this is the master node. So these three got automatically provisioned by the kops command that I ran. Alright, so this may take a while for it to get validated, a good 5 to 10 minutes. So what I'll do is I'll pause the video now and I'll come back once the cluster is up and running. It's been a good 8 to 9 minutes since I started my cluster. So let me validate now. Okay, seems good. So there's a master node, minimum 1, max 1, some nodes which are nothing but the slave nodes or the worker nodes. There are 2 of them, T2 micro, subnet. So my clusters seem to be up and running, and my cluster name is Simplilearn.in. So what I would want to do is now let me just log into the master and see if I can run some pods. So let me get back to my installation steps here. The validation cluster is done. So let me log into since my cluster name is Simplilearn.in, this is the way to log into my box. So let me get into my box. So if you see here, this is the host name of the machine that I'm currently in. If you see this is nothing but this cop server. This is a server. Now from here, I'm trying to get into the master box. Alright, so if you see, the IP address has changed. I was in a different box. I'm in a different box now. If I see host name, you'll find a different host name. So this is 153, which is nothing but the master node. Yep, it's 153. This is the particular host. So I'm getting into this machine now. So I started the cluster from my cop server here. It ran and brought up 3 nodes. So I'm actually getting into my master node and see if I can run some pods on it. Alright, so let me try kubectl get cluster info. Try kubectl get nodes. Alright, so there are 3 nodes here, master node and one master node and 2 worker nodes. So let me see if I have some pods here. Kubectl get pods. So there's no pod as of now. So what I'll try to do is let me just spin up a very simple pod just to check if my connections everything is correct or not correct. I have a simple Node.js application that I've built and I've got a container for that. This is already pushed to the Docker Hub registry. It is called Simplilearn Docker Hub, and the image name that I have here is called my node app, and I will use this image to power one of my pods that I will run. So this is the way in which I'm going to launch my pod. Let me show you these commands. Kubectl run, the name for my deployment that I'm going to run, -- image, and this is the image that is going to be powering my container. So this is Simplilearn Docker Hub / my node app -- replicas equal to I want 2 replicas to be running, and the port that I want to expose this particular pod is on 8080. So let me run this. As soon as this is run, it creates something called as a deployment. Alright, now let me just say I'm not really interested in the deployment. I'm interested in checking if at all the pods are up and running. So I will say kubectl get pod. Alright, so that was pretty fast. So I have 2 pods that are running here. These are 2 replicas because I asked for 2 replicas. These pods are running, so I can run kubectl describe pod pickup. Alright, I can pick up any of the pod name and see what is the pod, what is the information does it contain, from what is the image that is pulling, what is the image name, ID. This is actually running my pod, which is actually spinning up a container. Great, so far so good. So in Kubernetes, the pods are ephemeral, so they can be there at any time, cannot be at any time. If I need to expose my pod outside, I will have to create a service for my pod. So what I'll do is I'll create a very simple service by exposing this particular deployment. Before that, let me check kubectl get deployment. So there's a deployment that is created. The deployment name is Simplilearn app. So I will expose my deployment Simplilearn app as I'll just expose this. Let me see. Alright, I'm not specifying what type and all. I don't want to get into the complications of what are the different types of exposing this service and all that stuff. So if I don't specify anything, it gives me something called a cluster IP. So this is where my pod is actually exposed. So let me just check if at all this pod is up and running. I'll just try a simple curl command. Curl http : this is my cluster IP, and the port is 8080. If at all I hit this, it's actually hitting my application and giving me whatever. I put a simple sys.out kind of a thing where I'm just printing the container ID of whatever pod is serving being served out of. So I'm actually hitting my container and I'm getting this output from the container. So everything looks good. My container is up and running. So let me just go and clean it up. I will say kubectl delete deployment Simplilearn app. This should get rid of all the pods that I created. Kubectl get pod. Alright, these pods are interminating things. Let me just check kubectl get services. There's one service. I don't want this service. Let me delete that. Kubectl delete service. I want this. Alright, that sounds good. So let me come back to my host, my COP server from where I'm running. So I managed to successfully verify this pod, see if everything is up and running. So what I'll do is I'll just go ahead and complete this demo by going and getting rid of my cluster. So cops delete cluster -es. Alright, so this will ensure that it will clean up my complete cluster that I created. So I had 3 or 4 running instances. If you see that, all the 3 are shutting down because the COP server, which had COPS installed on it, has now got a mandate to go ahead and shut down and clean up the whole instances and all those things that are created as a part of my deployment.
On that note, if you are looking to learn Kubernetes, then get certified in DevOps with postgraduate program in DevOps by Simplilearn. This program offers blended learning that combines live online DevOps certification classes with interactive labs that gives you hands-on experience. You will gain expertise in tools like Terraform, Kubernetes, Maven, Ansible, Jenkins, Docker, JUnit, Git, and more. We prefer 1 year of prior experience to enroll in this course. So why wait? Enroll the course from the link in the description box.
So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker. And we can actually go through and understand what the problems specific companies have actually had and how they're able to use the two different tools to solve them. So our first one is with Bose. And Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing two primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the number one container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. Of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it. And you should be able to look and see whether or not you can add your own company to this list. We're going to break up the interview questions into three categories. It's going to be beginner, intermediate, and advanced. The beginner questions are really going to cover about 3/4 of the questions that we're going to ask here, and then the intermediate and advanced will finish out the final quarter. And the reason is that quite typically most interviews you'll be asked, intermediate to beginner level questions, mainly beginner level questions, just so you can demonstrate your understanding of Kubernetes, and then there's always one advanced question that gets thrown out just to make sure that you really do know what you're talking about and you've done at least 1 or 2 Kubernetes environment setups to be able to validate your experience. So let's kind of jump into that first section, which is, why is Kubernetes widely used? And your answer to this really comes into the fact that Kubernetes is widely used because of 3 distinct areas. One is that Kubernetes is an open source platform that is readily available for the management of containers and allows you to manage the deployment, scaling, and management of those containers. And so the first area is that it allows you for easy deployment of your containers, the ability to scale effectively within Kubernetes, not just vertically but horizontally for your containers. And then finally, the Kubernetes environment itself was really designed to make it easy to manage containers in small parts. Other key areas of why Kubernetes is popular is that Kubernetes is the single largest open source project out there. Since its launch in 2014, it's just grown in leaps and bounds. Around that project, there is just a huge community, both an online and physical community. There are just a large number of online groups that are supporting Kubernetes and allow you to get fast access to information. But in addition to that, there are also a lot of local meetup groups that cover specifically Kubernetes, whether as part of a DevOps group or as part of a dedicated Kubernetes group. The actual environment itself is a really robust way of being able to manage your containers. Containers are becoming the most popular way of being able to deploy cloud-based applications. Kubernetes is an effective and persistent storage environment. So Kubernetes is also able to effectively manage persistent storage, whether it's local storage as a SSD drive or a local hard drive, or whether it's cloud-based storage. And because of the way that Kubernetes is architecture, it's really designed for the cloud from the ground up. So it's a great way to get started in building out your cloud solutions. And then finally, the actual tools within Kubernetes are designed to help and manage the health and monitoring of the environment itself. So what is Google Container Engine? So the Google Container Engine is another open source solution, but it's designed for managing the Docker containers and clusters. And so Kubernetes is a container management solution, and Docker is the most popular container solution out there. And this is just a way of being able to bring the two effectively into each other, so that you can have Docker containers manage the application, and then Kubernetes manage the scale of your applications as they're vertically and horizontally scaled across your network. So what is the difference between Kubernetes and Docker? And this is important because Kubernetes and Docker are often dropped in the same sentence, and there's a lot of people that get confused between the two. So fundamentally, Kubernetes is about taking pods which contain containers which have applications in and deploying them at scale across a cloud network. Docker is the container solution itself. So the actual application itself is put into the Docker container. Because of this difference, Kubernetes is designed for auto-scaling, it's highly available, whereas Docker simply isn't, because it doesn't have to worry about that within the container itself. The Kubernetes environment will check for liveness and readiness of the health of the entire infrastructure, whereas with Docker, it's just really going to check the services that are coming in and out of the actual application itself within the container. Kubernetes is complicated to set up. It really is just simply complicated to set up, and what you'll find is a lot of cloud services will actually do the setup for you, whereas Docker is very easy to set up. As you would expect with the tolerance ratio, there is high fault tolerance with Kubernetes, whereas with Docker is low fault tolerance. And again, this is fundamental in the two different types of strategy that Kubernetes and Docker have. They're both connected tightly with each other, but they both do different things. So what are the notable features of Kubernetes? One is the ability to do container balance. Kubernetes always knows where to place a container within its entire network, within the pods and with its infrastructure. The services are managed for security, network, and storage. It is self-monitoring, so it goes in and is able to check its own nodes for health and the containers within the nodes, so it makes sure that the applications are always running effectively. You can do the scaling effectively, both vertically and horizontally within Kubernetes. The solution is open source, so there's no actual fee for the actual Kubernetes service itself. And Kubernetes allows for storage orchestration. What does it mean by storage orchestration? Storage orchestration is that you're able to access and share either local storage, such as a hard drive or SSD drive, or a cloud-based drive. And my preference is always to go with cloud-based drive, because then you're really positioning your solution to be a true cloud-based application. So what are the main advantages of Kubernetes? Well, you get automatic rollback for changes that go wrong. You're able to automate a lot of the processes that would have been manual processes previously. You're able to scale the resources both vertically and horizontally easily and quickly. And then these three areas, the rollback, automating services, and being able to scale, indirectly allows you to save money by reducing the amount of time and people working on your operations environment. So let's break out the architecture of Kubernetes. So you're going to be asked to explain how is Kubernetes architecture structured. And there are three key areas. There's the application layer, there's the Kubernetes layer, and then there's the infrastructure layer. We're going to start off with the infrastructure layer. And so the infrastructure layer is our base layer, and this is where you make your clusters for your collections of storage and networking resources within Kubernetes. And this is where you would have, if your databases are your data stored locally on a hard drive or in the cloud, your core network and the VMs that you'd be building out your infrastructure on. These allow you to group many machines together into a single unit so that you're able to scale up and down very easily to meet customer demand. So let's talk about the middle layer, which is the Kubernetes layer now. So if we're looking at our architecture for our Kubernetes layer, it's really broken down for the core operating system, the Docker container environment, and the Kubernetes code itself. And this is where you're able to take machines and pull them together as a cluster so that they work within that Kubernetes system. You have a master controller within Kubernetes that actually then will go ahead and manage the scheduler, the control manager, the API server. And then you'll be able to cluster all of these Kubernetes together so that they're all working and processing as one single unit. And then finally, let's look at the application layer where you actually have your apps. And so the application layer, where you have your pool and your services, Kubernetes will use API to connect in and out of this layer. It's to run your applications within containers, and you use instructions that are written in YAML or JSON to actually set up those containers. And you actually have the environment running on a plan that examines these instructions, so it keeps the entire environment healthy. API ecosystem is used to interact with the cluster. You don't have to do that by yourself, so make sure that you're referencing that the APIs are secured and connecting in and out of the system. And so you have your schedule and control manager actually from the Kubernetes environment doing the hard work, and then the workers themselves execute the commands that are coming from Kubernetes. So you will be asked to kind of dig into some of the key areas, such as explaining the master node and listing its components. So the master node is comprised of 4 key components. There's the cluster store, the controller manager, the scheduler, and the API server. So 4 key components. Remember, 4 fingers, 4 components. And then you're going to be asked to maybe dig deeper into what is a cluster within Kubernetes. And so a cluster is really a combination of resources such as machines into a single node. And then those nodes are pulled together and work as a single cluster as a whole. Kubernetes will work with that whole cluster. And then once you're actually working with that whole cluster, if a node fails or needs to be removed, Kubernetes is able to do that quickly and effectively. So let's talk a little bit about what are the different types of controllers in Kubernetes. And there are 5 types of control manager. You have the node controller, the service account, the token controller, the endpoint controller, and the replication controller. And so the node controller controls and handles the node in the system. The service account enables access controls in the system. The token controller cleans up any tokens for non-existent service accounts. The endpoint controller joins services in pods to the endpoint objects, and the replication controller manages the pod lifecycle. So what is the role of the cloud controller manager within this environment? And so the role of the cloud control manager is really to help manage persistent storage. And so persistent storage is storage that's either local storage to the physical machine, such as an SSD or hard drive, or cloud-based storage. And this allows the storage to be shared across the entire network. What is the role of the Kube API server and the Kube scheduler? So the Kube API server is responsible for the establishment of communication between the Kubernetes nodes and the master components, and it does this through APIs. The APIs themselves are all commands that are REST-based commands, and it implements an interface, which means different tools and libraries can communicate effectively with each other. So what is the role of the Kube API server and the Kube scheduler? So the Kube scheduler actually does the distribution of work across the entire infrastructure. So the actual YAML scripts that you've written are executed appropriately at the right time. So you're going to be asked to explain persistent volumes in Kubernetes. So a persistent volume is just a place where you can store data. Again, this can be local data, as in a hard drive local to the physical machine, or it can be cloud-based data. So what is a kubelet and a kube proxy? So a kubelet is a service responsible for conveying information to and from the control plane itself. The process, the kube proxy itself is responsible for maintaining the work and the status within the node server. In addition, every node in the cluster runs a simple network proxy, and kube proxy routes requests to the correct container in that node. In addition, you'll have some basic and primitive load balancing and management of the node from the proxy itself. There's additional layers of management that get done outside of the proxy, but the proxy is also there to help do some localized load management. So what is kubectl? So kubectl is your command line or terminal window interface that allows you to execute commands, and later in this video we'll actually go through some of those commands. etcd is the store that configures the details and essential values, such as key value pairs, that are distributed across your entire network. It also manages the network rules and the post-forwarding of activity. So what are the disadvantages of Kubernetes? Well, the first is it's really hard to install and configure, and this is why Azure and many cloud services such as Google Cloud will actually do the installation and configuration of Kubernetes for you. It does take a long time to get up and running with Kubernetes, not so much for the actual software, but your own experience of being able to use Kubernetes. It is not simple to manage the service. You actually have to have a lot of experience, and this is why people get paid a lot for Kubernetes skills. It's a difficult environment to get up and running and be effective in that management. Again, Kubernetes is just not an easy platform to learn. It takes a lot of time and effort. And one of the disadvantages is that while Kubernetes itself is free because it is an open source project, getting the people who are skilled to using Kubernetes is expensive. All right, so those were kind of the introductory questions that you can expect to be asked in your interview. The next set of questions are really going to be on an intermediate and advanced level, and these are the questions that will be thrown out. You see these as being the trick questions, which are really there to test that you have the skill set to be able to implement and manage Kubernetes within a company. So what happens if a master node fails? What happens if a worker node fails? How would Kubernetes manage that? Well, Kubernetes is really designed for this kind of scenario, and so you can actually look at it, and the response would be is that the pod itself does not get affected. Kubernetes will actually respond and fix the failed node, whether it is needs to be repaired, whether it needs to be restarted, or needs to be replaced. So what is a service role in Kubernetes? So a service role is an abstraction for the pods. It provides a virtual IP address and allows clients to connect to containers running in the pods using that virtual IP address. And the command that you would use to get that, we would use some of these kubectl commands. It's quite a simple one. It's kubectl get services, and you get a full list then of all the services that are available. So how do I do a rollback in deployment? So there's a couple of ways you can do the rollback. The first is if you want to see the rollout history deployment, you would write kubectl rollout history deployment and then in square brackets deployment. If you want to just restore to the previous rollout, the command would be kubectl rollout undo deployment and then in square brackets deployment, and that would take you back to the previous deployment. So what is an ingress controller? So an ingress controller really is a pod that manages that inbound traffic, and a prominent feature of that traffic is that it is secured with an SSL termination. And so what we're going to do to now address some of the key ways in which you can provide API securities on Kubernetes, and we have 8 of those. The first 4 are implementing TLS for your security. The second would be API authentication. The third is to make the kubeless protection, the kubeless protected via authorization mode equals webhook command. The fourth is to monitor RBAC failures. The fifth is to remove those default service account permissions. 6 would be to filter egress to Cloud API metadata APIs. The 7th is to use pod security policy to restrict container policies and protect the node. And the 8th and final is to keep the kube at the latest version. All right, let's go into some of the more advanced commands. And so the advanced questions that you're going to get are all going to be commands that you're going to be asked to write. Now, my advice for you for these questions is to make sure that you have some of these basic commands memorized. They don't have to be perfect when you're in the interview environment, but it's good to be able to get up to a whiteboard and actually write out what these commands are, just so you can actually demonstrate that you know what the commands are. The interviewer isn't going to ask you questions on how would you apply Kubernetes to the company that you're being hired for, because you simply don't have that knowledge, but they do want to be able to see clearly that you understand the commands and terminal window instructions that will be able to demonstrate how you would actually go in and access some of that information. So one of the first questions you might be asked is, how do you package Kubernetes applications? And so you would use the package manager within Kubernetes to be able to manage and configure and deploy applications into your cluster. And so here we have the Helm command that you would use. So what are init containers? And an init container gets executed before any other containers can run on the pod. And so you want to be able to illustrate what the init instructions would look like. And here we have an example, and I would again use this example and maybe memorize it for when you have this question come up in your interview. So what is the difference between a config map and a secret? And these are more fundamental. So a config map just has the instructions that are clearly available in plain text on what the cube is supposed to do, whereas the secrets are actually encrypted, and these are like passwords and other sensitive data that you don't want to have easily available. These are encrypted information that have to be decrypted to access the content. So if a node is tainted, is there a way to schedule the pods to that node? And the answer is no, there isn't. And so what you have to do then is schedule the pod to be fixed, and so that schedule the pod to fix the tainted node to allow for tolerations to that. And we have here the example code that you would use to do that. So how do you deploy a feature with zero downtime in Kubernetes? Well, Kubernetes is designed to be able to roll out applications with zero downtime. And here we have 4 examples using the rolling update as a strategy for zero downtime deployments in Kubernetes. Again, memorize one of these so you can actually illustrate how you use rollout to be able to deploy a zero downtime solution. So how do you monitor a pod that is always running? And so to do that, you would use the liveness probe to check the health of the application within the pod and see whether or not there are any failures or whether or not the pod itself needs to be restarted. So how do you drain traffic from a pod during a maintenance? So again, this is a simple command for you to remember, but to be able to drain an application so that it's easy for you to be able to do maintenance on the application, you would use the kubectl drain and then in square brackets the node name, and that would then temporarily drain that particular pod so you can actually do maintenance on it. What you have to then, and this would probably give you bonus points if you're in an interview, is then reference the uncordon command so that you can uncordon the actual node itself so that the pod itself can come back up into live and work as a fully functioning solution. So to be able to tie services to a pod or to a set of pods is that you can apply labels to the actual pods themselves and then use the labels as selectors to be able to glue services to that pod. And again, we have here an example of how you'd actually do that. And again, this is one of those where you probably won't be asked to write this out, but it'd be good to have this memorized. How do you get all pods on a node? And so the following command will actually go ahead and bring all the pods into a Kubernetes cluster. This is quite lengthy, and maybe you want to talk to how this would be done. But we have the instructions on how to do that right here. The important part is to make sure that you, when you're talking about the node name, that you reference to whoever you're interviewing, that what you would switch out to reference the actual nodes that you're trying to pull together into the Kubernetes cluster. So how do pods mount NFS volumes? And so in these examples here, we actually define the NFS server and then the pod and how you'd actually mount two together. Again, what you want to be able to do is illustrate why you would use YAML and how you'd actually then point to specific IP addresses within your Kubernetes environment, within either the production or test environments, to be able to illustrate how you would mount up those NFS volumes.
DevOps has emerged as a transformative approach fusing development and operations to streamline workflows, enhance collaboration, and boost efficiency. This dynamic fusion has given rise to a multitude of groundbreaking projects that are reshaping the industry. So in this explanation of the top 10 DevOps projects, we'll delve into the innovative solutions and tools that are catalyzing progress from automation and containerization to continuous integration and deployment. These projects not only facilitate agility but also drive excellence in software delivery, ensuring that DevOps remains at the forefront of modern technology. So join us as we embark on a journey through the most influential DevOps initiatives of our time. With that said, if these are the types of videos you'd like to watch, then hit that subscribe button and the bell icon to get notified. So let's start with why are DevOps skills crucial. Understanding DevOps is vital for optimizing the software development lifecycle. DevOps engineers need to master several key skills. Linux proficiency. Many firms prefer Linux for hosting apps and managing configuration systems. It's essential for DevOps engineers to be well versed in Linux as it's the foundation of tools like Chef, Ansible, and Puppet. Continuous integration and continuous delivery. CI ensures teams collaborate using a single version control system, while CD automates design, testing, and release, improving efficiency and reducing errors. Number 3. Infrastructure as code. Automation scripts provide swift access to necessary infrastructure, a critical aspect with containerization and cloud technologies. IAC manages configuration, executes commands, and swiftly deploys application infrastructure. Configuration management. Tracking software and operating system configurations ensures consistency across servers. Tools like Ansible, Chef, and Puppet simplify this process, making it efficient. At number 5, we have automation. DevOps aims for minimal human intervention, maximizing efficiency. Familiarity with automation tools like Gradle, Git, Jenkins, and Docker is essential for DevOps engineers. So these tools streamline development processes and enhance productivity. Moving on to the first project of the day, we have unlocking efficiency of Java application with Gradle. Meet Gradle, the versatile build automation tool transcending platforms and languages. This project helps you start on a journey of Java application creation, breaking it into modular subprojects and more. The main aim of this project is to help you master project initiation as a Java application, adeptly build it, and generate meticulous test reports. You will be well versed in running Java applications, crafting archives, and elevating your Java development pros. So dive in to transform your coding skills with Gradle. The source code for this project is linked in the description box below. Moving on to project number 2, unlock robust applications with Docker for web servers. Docker, the go-to container technology, revolutionizes services and app hosting by virtualizing operating systems and crafting nimble containers. This project focuses on creating a universal base image and helping you collaborate with fellow developers in diverse production landscapes. You will be dealing with taking web apps foundations in Python, Ruby, and Meteor. So master this project and you will yield Dockerfile efficiency like a pro, slashing build times and simplifying setups. So say goodbye to lengthy Dockerfile creation and resource-heavy downloads. The source code for this project is also mentioned in the description box below, so don't forget to check out. Moving on to project number 3, we have master CI/CD pipelines using Azure. In this Azure project, we harness Azure DevOps to create efficient CI/CD pipelines. This project mainly focuses on leveraging Azure DevOps Project. We deploy applications seamlessly across Azure services like App Service, Virtual Machines, and Azure Kubernetes Service or AKS. Utilizing Azure's DevOps Starter, we set up ASP.NET sample code, explore pre-configured CI/CD pipelines, commit code changes, and initiate CI/CD workflows. Additionally, we fine-tune monitoring with Azure Application Insights for enhanced performance insights. The source code for this project is also mentioned in the description box below. Moving on to the next project, elevating Jenkins communication, the remoting project. The Jenkins remoting project is all about enhancing Jenkins communication capabilities. It's an endeavor to bolster the Jenkins remoting library, creating a robust communication layer. This project incorporates a spectrum of features from TCP protocols to efficient data streaming and procedure calls. As a part of this project, you will start on the exciting journey of making Jenkins remoting compatible with bus technologies like ActiveMQ and RabbitMQ. To succeed in this project, a strong grasp of networking fundamentals, Java, and message queues is your arsenal. Dive in and join us in elevating the way Jenkins communicates with the world. Check out the link mentioned in the description box below for the source code. Moving on to project number 5, automated web application deployment with AWS, your CD pipeline project. In this project, you will create a seamless continuous delivery pipeline for a compact web application. Your journey begins with the source code management through a version control system. Next, discover the art of configuring a CD pipeline enabling automatic web application deployment whenever your source code undergoes changes. Embracing the power of GitHub, AWS Elastic Beanstalk, AWS Code Build, and AWS Code Pipeline. This project is your gateway to streamlined, efficient software delivery. The source code for this project is linked in the description box below. Moving on to the next project, containerized web app deployment on GKE, scaling with Docker. This project will help you discover the power of containerization with this project. You will learn how to package a web application as a Docker container image and deploy it on a Google Kubernetes engine or GKE cluster. You can watch your app scale effortlessly to meet user demands. These hands-on projects cover packaging your web app into a Docker image, uploading it to artifact registry, creating a GKE cluster, managing auto-scaling, exposing your app to the world, and seamlessly deploying newer versions. You get to unlock the world of efficient, scalable web app deployment on GKE. The source code for this project is linked in the description box below. Moving on to project number 7, mastering version control with Git. In a world of software development, mastering a version control system is paramount. Version controlling enables you for code tracking, version comparison, seamless switching between versions, and collaborating among developers. Your journey in this project will begin with the fundamental art of saving code in a VCS, taking the scenic route to set up a repository. You can then start on a quest through code history, unraveling the mysteries of version navigation. Navigating through branching, a deceptively intricate task, is next on your path. By the end of this project, you will be fully equipped to conquer Git, one of the most powerful version control system tools in the developer's arsenal. The source code for this project is mentioned in the description box below. Moving on to the next project, effortless deployment, running applications with Kubernetes. The major focus of this project is to help you harness a straightforward web service that handles user messages, akin to a voicemail system for leaving messages. Your mission, you ask. You get to deploy this application seamlessly with Kubernetes, then Dockerize it. By mastering this fundamental step, you will unlock the power to run your application in Docker containers, simplifying the deployment process. The source code for this project is mentioned in the description box below, so don't forget to check it out. Moving on to the project number 9, mastering Terraform project structure. This project will help you maintain and extend the efficiency of Terraform projects in everyday operations. A well-structured approach is essential. This project unveils the art of organizing Terraform projects based on their purpose and complexity. So harness the power of key Terraform features, including variables, data sources, provisioners, and locals, to craft a streamlined project structure. By the end, your project will effortlessly deploy an Ubuntu 20.04 server on DigitalOcean. Configure an Apache web server and seamlessly point your domain to it. Level up your Terraform game with proper project structuring and practical application. Check out the link mentioned in the description box below for the source code. Moving on to the last project of the day, we have efficient Selenium project development and execution. In the world of test automation, Selenium projects play a pivotal role. They enable seamless test execution, report analysis, and bug reporting. This proficiency not only accelerates product delivery but also elevates client satisfaction. By the end of this project, you will master the art of building Selenium projects, whether through a Java project or a Maven project, showcasing your ability to deliver high-quality results efficiently.
Hello, this is Matthew from Simplilearn, and today we're going to go through part 1 of a 2-part series on interview questions that you are likely to be asked if you are interviewing for a job that focuses on DevOps. So there are approximately 7 sections that we cover in DevOps. We go from general DevOps questions, source code management with tools such as Git, continuous integration, and here we'll focus on Jenkins, continuous testing with tools such as Selenium, and then you also have the operations side of DevOps, which is your configuration management with tools such as Chef, Puppet, and Ansible, containerization with Docker, and then continuous monitoring with tools such as Nagios. So let's just get into those general DevOps questions. So one of the questions that you're going to be asked is, how is DevOps different from Agile? And the reality is that DevOps is a cultural way of being able to deliver solutions that's different from Agile. If we look at the evolution of delivery over the last 5 to 10 years, we've gone from waterfall based delivery to Agile delivery, which is on sprints, to where we are with continuous integration and continuous delivery around DevOps. The whole concept of DevOps is culturally very, very different from Agile. And the difference is that you're looking at being able to do continuous releases. What does that mean? The difference is that you want to be able to send out code continuously to your production environment. That means the operations team, the development team have to be working together. That means that any code that gets created has to be able to go to production very quickly, which means you need to be testing your code continuously. And then then that production environment must also be able to be tested continuously, and any changes or any errors that come up have to be communicated effectively and efficiently back to the dev and op team. Another area in which I see that DevOps is different is really the response that we have for how we engage with the customer. So the customer is coming to your website, to your mobile app, to your chatbot, or any digital solution that you have, and has an expectation. When you're going through and actually doing a DevOps paradigm, the old model would be that you would capture requirements from the customer, then you do your development, then you do your testing, and there would be these barriers between each of those. As we move faster through from waterfall to agile, what we saw is that with agile, we were able to respond much faster to customer demands. So instead of it being weeks or months, sometimes in some cases years between releases of software, what we saw was a transition to weeks and months for releases on software. Now we see with DevOps is that the release cycle has shrunk even further, with the goal of continuously delighting the customer. How further has that release cycle shrunk to? There are companies that have gone from having releases of once a week or once every 2 weeks or once a month to now having multiple releases a day. Indeed, some companies have up to 50 releases a day. This isn't something to also bear in mind is that each of those releases are tested and verified against test records so that you can guarantee that the code that's going to production is going to be good continuous code. So what are the differences between the different phases of DevOps? So effectively, there are two main phases of DevOps. There's the planning and coding phase, and then there's the deploying phase. And you have a tool such as Jenkins that allows you to integrate between both environments. Some of the core benefits that you may have to DevOps are going to be some technical benefits and some business benefits. So when somebody asks you what are the benefits of DevOps, you can reply that from a technical point of view, you're able to use continuous software delivery to constantly push out code that has been tested and verified against scripts that have been written and approved. You can be able to push out smaller chunks of code so that when you have an issue, you're not having to go through massive blocks of code or massive projects. You're going through just very small microservices or small sections of code, and you're able to detect and correct problems faster. On the business side, the benefits are absolutely fantastic. From a customer that's coming to your website or to your mobile app, they're going to see responses happening continuously so that the customer is always aware that you as a company are listening to their demands and responding appropriately. You're able to provide a more stable environment, and you're able to scale that environment to the demands of the number of customers that are using your services. So how will you approach a project that needs to implement DevOps? So this is really an exciting area for you to be in. So there are effectively 3 stages when it comes to actually working in a DevOps. The first stage is an assessment stage, and think of this as the back of the napkin ideation stage. This is where you are sitting with a business leader and they're giving you ideas of what they would like to see from feedback that they've had from their customers. This is blue sky opportunity. This is thinking of big ideas. That second stage, and this often comes as a fast follow to stage 1, is actually proving out that concept. So developing a proof of concept. And a proof of concept can actually be multiple different things. So it could be something as simple as a wireframe, or it could be something that is as complex as a mini version of the final application. Depending on the scope of the work that you're delivering will really depend on how complicated you want the POC to be. But with that in mind, whatever choice you make, you have to be able to deliver enough in the POC so that when you present this to a customer, they're able to respond to that creation that you've developed and able to give you feedback to be able to validate that you are going with the right solution and able to provide the right product to your customers. That third stage is where you get into your DevOps stage, and this is just the exciting part. This is where the rubber hits the road and you start releasing code based on a backlog of features that are being requested for the solution. In contrast to doing agile delivery where you just continuously work through a backlog, With DevOps, what you're also looking at is putting in analytics and sensors to be able to validate that you are being successful with the solution that's being delivered. So that once you actually start delivering out code that customers can interact with, you want to be able to see what are the pieces of the solution that they are using, what do they like, what is complicated, where are the failure points, and you want to use that data and feed that back into your continuous integration and have that as a means to be able to backfill the demand of work that gets completed in the backlog. So what is the difference between continuous delivery and continuous deployment? So continuous delivery is based on putting out code that can be deployed safely to production. It ensures that your businesses and functions are running as you would expect them to be. So it's going through and completing the code that you'd actually see. Continuous deployment, in contrast, is all about ensuring that you're automating the deployment of a production environment. So you're able to go through and scale up your environment to meet the demands of both the solution and the customer. This makes software development and release processes much more faster and more robust. So if we look here, we can actually see where continuous integration and continuous deployment come hand in hand. So when you actually start out with the initial pushes of your code, that's where you're doing your continuous integration and your continuous delivery. And then at some point, you want to get very comfortable with deploying the code that you're creating so that it's being pushed out to your production environment. One of the things that's great about working with the tools that you use in a DevOps continuous integration and continuous delivery model is that the development tools that you use, the containerization tools, the testing tools, should always reflect the production environment. And what this means is that when you actually come to deploying solutions to production, there are no surprises because your development team have been working against that exact same environment all the way through. So a question that you'll also be asked is, what is the role of a configuration management in DevOps? And so the role of configuration management really has three distinct areas. The first, and this is really the obvious one, and this is the one where you probably already have significant experiences, is the ability to manage and handle large changes to multiple systems in seconds rather than days, hours, or weeks, as may have happened before. The second area is that you want to also demonstrate the business reasons for having configuration management. And the business reason here is that it allows IT and infrastructure to standardize on resource configurations. And this has a benefit in that you're able to do more with fewer people. So instead of having a large configuration team, you can actually have a smaller, more highly skilled team that's able to actually manage an even larger operational environment. And thirdly, you want to be able to highlight the ability to scale. So if you have configuration management tools, you're able to manage a significant number of servers and domains that may have multiple servers in. It allows you to effectively manage servers that are deployed on cloud or private cloud and allow you to do this with high accuracy. So how does continuous monitoring help in maintain the entire architecture of the system? So when this question comes up, you want to dig in and show your knowledge on how configuration and continuous monitoring is able to control an entire environment. So the number one topic that you want to bring up when it comes to continuous monitoring is that with being able to effectively monitor your entire network 24/7 for any changes as they happen, you're able to identify and report those faults or threats immediately and respond immediately for your entire network instead of having to wait, as it happens sometimes, for a customer to email or call you and say, hey, your website's down. Nobody wants that. That's an embarrassing thing. The other three areas that you want to be able to highlight are the ability to be able to ensure that the right software and the right services are running on the right resources. That's your number one takeaway that you want to be able to give of continuous monitoring. The second is to be able to monitor the status of those servers continuously. This is not requiring manually monitoring, but having an agent that's monitoring those servers continuously. And then the third is that by scripting out and continuously monitoring your entire environment, you're creating a self-audit trail that you can take back and demonstrate the effectiveness of the operations environment that you are providing. So one of the cloud companies that is a strong advocate for DevOps is Amazon's Web Services, AWS, and they have really 5 distinct areas that you can zero in on for services. So when the question comes up, what is the role of AWS in DevOps? You want to really hold out your hand and list off 5 areas of focus using your thumb and finger. So you want to have flexible services, built for scale, automation, secure, and a large partner ecosystem. And having those 5 areas will really be able to help demonstrate why you believe that AWS and other cloud providers, but AWS is certainly the leader in this space, are great for being able to provide support for the role of DevOps. So one of the things that we want to be able to do effectively when we're releasing any kind of solution is to be able to measure that solution. And so KPIs are very important. So you will be asked for 3 important DevOps KPIs. And so 3 that really come to mind that are very effective. The first one is mean time to failure recovery. And what this talks about is what is the average time does it take to recover from a failure? And if you have experience doing this, then look at the experience that you have and use a specific example where you are able to demonstrate that mean time to failure recovery. The second is deployment frequency. And with deployment frequency, you want to be able to discuss how often do you actually deploy solutions and what actually happens when you're actually doing those deployments, and what does the impact to your network look like when you're doing those deployments. And then the third one is really tied to that deployment frequency, which is around what is the percentage of failed deployments. So how many times did you deploy to a server and something happened where the server itself failed? What we're looking for when you're going through and being asked for these KPIs is experience with actually doing a DevOps deployment and being able to understand what DevOps looks like when you're pushing out your infrastructure. And then the second is being able to validate that self-auditing ability. And one word of caution is don't go in there and say that you have 100% success. The reality is that servers do degrade over time, and you maybe want to talk about a time when a server did degrade in your environment and use that as a story for how you were able to successfully get over and solve that degradation. So one of the terms that is very popular at the moment is infrastructure as code. And so you're going to be asked to explain infrastructure as code. And really, it's something that actually becomes a byproduct of the work you have to do when you're actually putting together your DevOps environment. And infrastructure as code really refers to the writing of code to actually manage your environment. And you can go through many of the other tools that we've covered in this series, but you'll see that XML or Ruby or YAML are used as languages to describe the configuration for your environment. This allows you to then create the rules and instructions that can be read by the machines that are actually setting up the physical hardware versus a traditional model, which is having software and installing that software directly onto the machine. This is really important when it comes to cloud computing. There really is a strong emphasis of being able to explain infrastructure as a service, and infrastructure as code is fundamental to the foundation to infrastructure as service. And then finally, it allows you to be able to talk about how you can use scripted languages such as YAML to be able to create a consistent experience for your entire network. All right, so let's now get into the next section, which is source code management. And we're going to focus specifically on Git. The reason being is that Git is really the most popular source code management solution right now. There are other technologies out there, but for the types of distributed environments that we have, source code management with Git is probably the most effective. So the first question you'll be asked when it comes to Git is to talk about the difference between centralized and distributed version control. And if we look at the way that the two are set up, older technologies such as older versions of Team Foundation Server, though the current version does actually have Git in it, but older versions required a centralized server for you to check in and check out of code. The developer in the centralized system does not have all the files for the application. And if the centralized server crashes, then you actually lose all of the history of your code. Now, in contrast, a distributed model, actually, we do check in our code to a server. However, for you to be effective and building out your solution, you actually check out all of the code for the solution directly onto your local development machine. So you can actually have a copy of the entire solution running on your local machine. This allows you to be able to work effectively offline. It really allows for scalability when it comes to building out your team. So if you have a team that may be in Europe, you can actually then scale that team with people from Asia, from North America or South America very easily, and not have to worry about whether or not they have the right code or the wrong code. And in addition to that, if the actual main server where you're checking in your code does crash, it's not a big deal because you actually have, each person has a copy of the code. So as soon as the server comes back up, you're able to check back in and everybody's running back as if there was nothing had happened at all. So one of the questions you'll be asked is to give the answer to some of the commands you use for working with Git. So if you were to be asked a question is, what is the Git command that downloads any repository from GitHub to your computer? On the screen we have 4 options. We have Git push, Git fork, Git clone, and Git commit. The answer in this instance would be Git clone. Now, if you want to be able to push code from your local system to a GitHub repository using Git, then first of all, you want to be able to do is connect the local repository to a remote repository. And in the example, you may want to talk about using the command git remote add origin and then the actual path to a GitHub repository. You could, if you wanted to, actually at this point also talk about other repositories such as GitLab that you can also work with, or a private Git repository that would be used just for the development team. Once you've actually then added the local repository into your local computer, then the second action you want to use is a push, which is to actually push your local files out to the master environment. So you use the command git push origin master. So one question you may be asked is, what is the difference between a bare repository and a standard way of initializing a Git repository? So let's look through what is the standard way. So the standard way using git init allows you to create a working directory using the command git init. And then the folder that creates is the folder that creates all the revision history related to the work that you're doing. In contrast, using the bare way, you have a different commands for setting that up. So it would be git init --bare, and it does not contain any working or checked out source files locally on your machine. In addition, the revision history is actually stored in the root folder versus a subfolder that you would have with the normal git init initialization. So which of the following CLI commands would you be used to rename a file? So we have git rm, git mv, git rm-r, or none of the above. Well, in this instance, it would be git mv. A question that you'll be asked around commit is going to be, what is the process to revert a commit that has already been pushed and made public? And there are 2 ways you can address this. The first is to actually address the bad file in the new commit, and you can use the command git commit -m and then put in a comment for why that file is being removed. The second is to actually create a new commit that actually undoes all the changes that were made with the bad commit. And then to do that, you would use git revert and then the commit ID, and the commit ID could be something such as 56DE0938F, but you'd have to find that from the commit that you had made, but that would allow you to revert any bad files that you had submitted. So there are 2 ways of being able to get files from a Git repository, and you're going to be asked to explain the difference between git fetch and git pull. So git fetch allows you to fetch and download only new data from a new repository. It does not integrate any of the new data into your working files, and it can be undone at any time if you wanted to break out the remote tracking branches. In contrast, git pull updates the current head branch with the latest changes from the remote server. So you get all of the files downloaded. It downloads new data and integrates it with the current working files you have on your system, and it tries to merge remote changes with your local ones. So one of the questions you'll get asked about Git is, what is a Git stash? So as a developer, you will be working on the current branch within a solution. But what happens if you come up with an idea where it's something that will take a different amount of time for you to be able to complete, but you don't want to interrupt the mainline branch? So what you can actually do is you can actually create a branch that allows you to start working on your own work outside of the mainline branch. And this is called Git stash. It allows you to be able to modify your files without interrupting the mainline branch. So once you start talking about branching in Git, be prepared to answer and explain the concept of branching. So essentially what it allows you to do is have a mainline master branch that has all the code that the team is checking in and checking out against, but allows you to have an indefinite number of branches that allows for new features to be built in parallel to the mainline branch, and then at some point be reintroduced to the mainline branch to allow the team to add in new features. And so if we look through the merge and git rebase, these are the two features that you'd be using continuously to be able to talk about how you take a branch and merge it back into the mainline branch. So on the left hand side we have git merge, which allows you to take the code that you're creating and merge it back into the master. On the right hand side what you have is a slightly different approach. This is for projects where you reach a point in a project where you go, okay, we're going to effectively restart the project at this point in time, and we want to ignore the complete history that's happened before that. And that's called git rebase, and that would allow you to rewrite the project history by creating a brand new mainline branch that ignores all other previous branches that have happened before it. You can, if you want to, very quickly and easily find out all the files that have been used to make a particular commit. So when somebody asks you the question, how do you find a list of files that has been changed in a particular commit, you can actually say that all you have to go is find the command git diff-tree-r and then the hash that you would use for the commit, and that would actually then give you a breakdown of all the files that have been made with that particular commit. A question that you'll be asked when you're talking about merging files is, what is a merge conflict in Git and how can it be resolved? So essentially a merge conflict is when you have two or more branches that are competing with commits in Git, and you have to be able to determine which is the appropriate files that need to be submitted. And this is where you would go in, and to actually help resolve this issue, you'd actually go in and manually edit the conflicted files to select the changes you want to keep in the final merge. So let me go through the steps that you would take to be able to illustrate this when you're talking about this particular question in your interview. There are essentially 4 stages. The first would be under the repository name, you want to select a pull request, and you want to be able to show how that pull request would be demonstrated inside of GitHub. So within the pull request, there's going to be a highlight of conflict markers, and you'll be able to select which conflicts you want to keep and which you want to merge and which ones you want to change. So it's a step through how you would actually resolve a merge conflict. The first step would be under GitHub. You want to be able to pull the repository name and then the pull request around that repository. In the pull request list, click the pull request with a merge conflict and that you'd like to be able to resolve. And that will pull up a file that will list out all of the conflicts for you. Near the bottom of that file will be a list of the requests that need to be resolved. And then if you need to make a decision on which branches you want to keep or which ones you want to change, that will have to be something you have to put in instructions inside of the file. You'll actually see that there are conflict markers within the instructions which are going to ask you which files you want to change and which ones you want to keep. If you have more than one merge conflict in your file, scroll down to the next set of conflict markers and repeat steps 4 and 5 until you resolve all of the conflicts. you will want to mark your file as resolved in GitHub so that the repository knows that you are having everything resolved. If you have more than one file with a conflict, then you want to go then onto the next file and start working on those files and just keep repeating the steps we've done up to this point until you have all of the conflicts resolved. And then once you have all of the resolutions created, then you want to select the button which is commit merge and then merge all your files back into GitHub, and this will take care and manage the resolution of the merge conflict within GitHub. So you can also do this through command line, and with the command line you want to use git bash, and so you want to, as a first step, open up git bash and then navigate to the local git repository in command line using the cd change directory, and then list out the actual folder where you actually are putting all of your code. And then you want to be able to generate a list of the files that are affected with the merge conflict. And in this instance here, you can actually see the file styleguide.md has a merge conflict in it. And as before, with working with GitHub, you actually go through and use a text editor, and you can use any text editor. But as you go through and edit out what you want to keep and what you want to manage in your conflict, so you actually have a resolution that's being created, so that you'll be able to then, once you're using the conflict markers, you can actually merge your files together so that the solution itself will allow you to incorporate your commits effectively into the resolution. Once you've gone through and applied your changes, you're able to then merge the conflicted commits into a single commit and able to push that up to your remote repository. All right, let's talk about the next section, which is continuous integration with Jenkins. So the first question you'll be asked about with Jenkins is explain a master-slave architecture of Jenkins. So the way that Jenkins is set up is that the Jenkins master will pull code from your remote Git repository such as GitHub and will check that repository every time there is a code commit. It will distribute the workload of that code and the tests that need to be applied to that code to all of the Jenkins slaves. And then on request, the Jenkins master and the slaves will then carry out all the builds and tests to be able to produce test reports. The next question you'll be asked is, what is a Jenkins file? And simply put, a Jenkins file is a text file that has a definition of the Jenkins pipeline and is checked into a source code repository. And this really allows for three distinct things to happen. One, it allows for a code review and iteration of the pipeline. It permits an audit trail for that pipeline, and also provides a single source of truth for the pipeline, which can be viewed and edited. So which of the following commands runs Jenkins from the command line? Is it java-jar jenkins.war, java-war jenkins.jar, java-jar jenkins.jar, java-war jenkins.war? And the answer is A, java-jar jenkins.war. So when working with Jenkins, you're going to be asked what are the key concepts and aspects of working with a Jenkins pipeline. And you want to really hold out your fingers here and go through 4 key areas, and that is pipeline, node, step, and stage. So pipeline refers to the user-defined model of a CD continuous delivery pipeline. Node are the machines which are part of that Jenkins environment within the pipeline. Step is a single task that tells Jenkins what to do at that particular point in time. And then finally, stage defines a conceptually distinct subset of tasks performed through the entire pipeline. And tasks could be build, test, and deploy. So which of the following file is used to define dependency in Maven? And do we have A, build.xml, B, pom.xml, C, dependency.xml, or D, version.xml? And the answer is pom.xml. Working with Jenkins, you're going to be asked to explain the 2 types of pipeline used in Jenkins along with the syntax. And so a scripted pipeline is based on GroovyScript as the domain-specific language for Jenkins. And there are 1 or more node blocks that are used throughout the entire pipeline. On the left-hand side, you can actually see what the actual script would look like, and the right-hand side shows what the actual declaration for each section of that script would be. The second type of Jenkins pipeline is a declarative pipeline. And a declarative pipeline provides a simple and a friendly syntax to define what the pipeline should look like. And then you can actually, at this point, use an example to actually break out how blocks are used to define the work completed in a declarative pipeline. So how do you create a copy and backup of Jenkins? Well, to create a backup, periodically back up Jenkins to your Jenkins home directory, and then create a copy of that directory. It's really as simple as that. A question you'll be asked as well is, how can you copy Jenkins from one server to another? Well, there are three ways to do that. One is you can move a job from one installation of Jenkins to another by copying the corresponding job directory. The second would be to create a copy of an existing job directory and making a clone of that job directory but with a different name. And the third is to rename an existing job by renaming a directory. So security is fundamental to all the work that we do within DevOps, and Jenkins provides the center core to all the work that gets completed within a DevOps environment. There are three ways in which you can apply security to authenticate users effectively. And when you are asked about this question of security within Jenkins, the three responses you want to be able to provide is A, Jenkins has its own internal database that uses secured user data and user credentials. B is you can use a LDAP or lightweight directory access protocol server to be able to authenticate Jenkins users. Or C, you can actually configure Jenkins to authenticate by using such as OAuth, which is a more modern method of being able to authenticate users. You're going to be asked how to deploy a custom build of a core plugin within Jenkins. And essentially, the 4 steps that you want to go through are, first of all, copying the .hpi plugin file into the Jenkins home plugins subdirectory. You want to remove the plugin's development directory if there is one. You want to create an empty file called plugin.hpi.pinned. And once you've completed these 3 steps, restart Jenkins and your custom built plugin should be available. How can you temporarily turn off Jenkins security if the administrative user has locked themselves out of the admin console? Well, this doesn't happen very often, but when it does, it's good to know how you can actually get into Jenkins and be able to resolve the problems of authenticating effectively into the system as an administrator. So when you want to be able to get into a Jenkins environment, what you want to be able to do is locate the config file. You should see that it's set to true, which allows for security to be enabled. If you then change the user security setting to false, security will be disabled, allowing you to make your administrative changes and will not be re-enabled until the next time Jenkins is restarted. So what are the ways in which a build can be scheduled and run in Jenkins? Well, there are 4 ways in which you can identify the way a build can be scheduled or run in Jenkins. The first is when source code management commits new code into the repository. You can run Jenkins at that point. The second can be after the completion of other builds. So maybe you have multiple builds in your project that are dependent to each other, and when so many other builds have been executed, then you can have Jenkins run. You can schedule builds to run at a specified time. So you may have nightly builds of your code that illustrate the changes in the solution you're building. And then finally, you also can manually build an environment on request. Occasionally, you will want to also restart Jenkins. And so it's good that when a question around how do you restart Jenkins manually comes up, that you have the answers. And there are 2 ways in which you can do it. One is you can force a restart without waiting for builds to complete by using the Jenkins URL that you have for your environment /restart, or you can allow all running builds to complete before restart are required, and in which case you would use the command of the URL for your Jenkins environment /safe restart. So let's go into the 4th and final section of this first video, which talks about continuous testing with Selenium. So the first question you will be asked most likely around Selenium are, what are the 4 different Selenium components? And again, you will want to hold open your fingers because there are 4 distinct environments. You have Selenium Integrated Development Environment, or Selenium IDE. You have Selenium Remote Control, or Selenium RC. You have Selenium WebDriver, and then Selenium Grid. You'll be asked to explain each of those areas in more detail, but let's start off by looking at Selenium Driver. What are the different exceptions in Selenium WebDriver? So it's useful to remember that an exception is an event that occurs during the execution of a program that disrupts the normal flow of that program's instructions. And so we have 4. We have a timeout exception, an element not visible exception, no such element exception, and a session not found exception. And each of those, if we step through them, are the 4 different types of exceptions that can be thrown up when using the Selenium WebDriver. So as we evolve in our digital world with the different types of products that are available for us to be able to build solutions onto multiple platforms, you're going to be asked, can Selenium and other DevOps tools run in other environments? And so a good question around this is, can Selenium test an application in an Android web browser? And the short answer is absolutely yes, it can. But you have to use the Android driver for it to be able to work. So you want to be able to talk about the 3 different types of supported test within Selenium. So when the question comes up, what are the different test types supported by Selenium, you can answer it. And there are 3 different types of tests. First is a functional test. Second is a regression test, and third is a load testing test. The functional test is a kind of black box testing in which test cases are based on a specific area or feature within the software. A regression test helps you find any specific areas that functional tests or non-functional areas of the code wouldn't be able to detect. The load testing test allows you to monitor the response of a solution as you increase the volume of hits in how you're using the code are put onto it. An additional question you'll be asked is, how can you get a text of a web element using Selenium? Well, the get command is used to retrieve text of a specific web element. It's important to remember, however, that the command does not return any parameters, but just returns a string value. So you want to be able to capture that string value and discuss about it. A question you'll be asked around Selenium is, can you handle keyboard and mouse actions using Selenium? And the answer is yes, you can, but you have to make sure that you're using the Advanced User Interaction API. And the Advanced User Interaction API is something that can be scripted into your tests, and it allows you for capturing methods such as a click and hold and drag and drop mouse events, and then keyboard down or keyboard up key release events, so that if you want to capture, say, the use of Control Shift or a specific function button off the keyboard, you'd be able to capture those. Of the following 4 elements, which of these elements is not a web element method? A, get text. B, size. C, get tag name. D, send keys. And it's B, size. You're going to be asked to explain what is the difference for when we use find element or find elements. And so if we look at find element finds the first element in the current web page that matches the specified locator value. In contrast, find element finds all of the elements on the web page that matches the specified value. When using WebDriver, what are the driver close and driver quit commands? And these are 2 different methods used to close a web browser session in Selenium. So driver close will close the current web browser on which your focus is set, and driver quit closes all the browser windows and ends the WebDriver session completely. The final question that you are likely to be asked in using Selenium is, how can you submit a form using Selenium? Well, in this instance, that's relatively easy. The following lines of code will let you submit a form in Selenium, which would be web element el equals driver.findElement, and then you put in the ID and the element ID, and then L submit, open close parentheses, semicolon. So let's just get into the first section, which is configuration management. So one of the questions that you'll get asked right away is, why do you have SSL certificates used for Chef? Really fundamentally, your immediate answer should be security. SSL provides for a very high level of private security and private and public key pairing. This really is essential to ensure that you have a secure environment throughout your entire network. The second part should be that if you're using SSL and you're using the private public key model within SSL, you're able to guarantee the systems on your network that the Chef, that you'll be able to validate that the nodes within your network that Chef is validating against actually are the real nodes themselves, not imposters. So you will also be asked some questions such as the following. Which of the following commands would you use to stop or disable the HTTP service when the system boots? And you'll typically get 4 responses, and there'll be hashtag systemctl disable httpd.service, or is it system disable http.service, system disable httpd, or the final option, which is systemctl disable httpd.service. Your answer should be the first one, which is hashtag systemctl disable http.service. So Chef comes with a series of tools that allow it to function effectively, and one of the tools that you're going to be asked about is, what is Test Kitchen? And Test Kitchen is essentially a command line tool that allows you to be able to test out your cookbook before you actually deploy it to a real node. So some of the commands that you would use are, for instance, if you want to create an instance of Test Kitchen, you would do kitchen create. If you want to destroy an instance after you created it, you do kitchen destroy. And if you want to be able to combine multiple instances, you would do kitchen converge. So a question you'll get is around Chef is, how does Chef Apply differ from Chef Client? So fundamentally, the difference between them is that Chef Apply will validate the recipe that you're working on, whereas Chef Client looks to apply and validate the entire cookbook that's run in your server environment. So one is focused on the recipe and the other is focused on the entire cookbook. So there are some differences when you're working with different command lines. So for instance, when you're working with Puppet and you're working with one version of Puppet and you want to do, what is the command to sign a requested certificate? The top example here is for Puppet version 2.7, whereas the lower option here is for Puppet version 3. And that's something to bear in mind when you're going through your interview process, is that the tools that are used within a continuous integration, continuous delivery DevOps model do vary. And so you want to be able to talk knowledgeably about the different versions of the tools so that when you're talking to your interviewer, you're able to show the deep knowledge that you have. Which open source or community tools do you use to make Puppet more powerful? And essentially this question is going to be asking you to look beyond the core foundation of Puppet itself. And so the 3 options you have is being able to track configurations with Jira, which you should be doing anyway, but it's a great way to be able to clearly communicate the work that's being done with Puppet. Version control can be extended with Git. And then the changes should be passed through Jenkins. So the 3 tools you want to be looking at: integration with Jira, Git, and Jenkins. So what are the resources in Puppet? Well, fundamentally, there are 4. The resources are a basic unit of any configuration management tool. They are the features of the nodes. They are the written catalog and the execution of the catalog on a node. So as we dig deeper into Puppet, one of the things that you are likely to be asked regarding Puppet is, what is a class in Puppet? And so a class in Puppet is really the name blocks in your manifest that contain the various configurations. And this can include services, files, and packages. And we have on the screen here an example of what a class would look like when you write it out. And you may want to memorize just one class. Don't memorize just a whole set of classes. Just memorize one. The person that's interviewing you is just really looking for someone who has a working knowledge. They're not looking for you to have memorized complete massive classes, but having one small class to be able to illustrate the experience you have is extremely valuable to the interviewer, particularly if it's a technical interview. So as we move into Ansible, one of the things that you're going to be asked around Ansible is, what is Ansible role? So a role is an independent block of tasks and variable files and templates embedded inside of the playbook. So the example we have here on the screen actually shows you one role within a playbook. And in this role, it is to install Tomcat on a node. Again, as with previous question within Puppet of a class, it's probably good to have memorized just one or two roles so you can talk knowledgeably about Ansible when you're having your interview. So when you're working with Ansible, when should you be using the curly brackets? And so just as a frame of reference, there's often two different ways that these kind of brackets are referred to. They're either referred to as French brackets or curly brackets. Either way, what you'll be wanting to ask is, when would you use these specific types of brackets within Ansible? And really, the answer comes down to two things. One is that it makes it easier to distinguish strings and undefined variables. And the second is for putting together conditional statements when you are actually using variables. And the example we have here is this prints the value of, and we have foo, and we have to then put in the variable conditional statement of foo is defined as something. So what is the best way to make content reusable and redistributable with Ansible? And there's really essentially three. The first is to include a submodule or another file in your playbook. The second is to import an improvement of an include, which ensures that a file is added only once. And then the third is roles to manage the tasks within the playbook. So a question you will be asked is, provide a differences between Ansible and Puppets. So if we look at Ansible, it's a very easy agentless installation. It's based on Python. You can configure it with YAML, and there are no support for Windows. In contrast, Puppet is an agent-based installation. It's written in Ruby. The configuration files are written in DSL, and it has support on all popular operating systems. So we dig deeper into the actual architecture. Ansible, it has a much more simple architecture, and it's definitely a push-only architecture. In contrast to Puppet, it's a more complicated but more sophisticated architecture where you're able to have a complete environment managed by the Puppet architecture. So let's get on to our next section, which is containerization. So let's go through, and you're going to be asked to explain what the architecture of Docker is. And Docker really is the most popular containerization environment. So Docker uses a client-server architecture. The Docker client is a service which runs in a command line. And then the Docker daemon, which is run as a REST API within the command line, will accept the requests and interacts with the operating system in order to build the Docker images and run the Docker containers. And then the Docker image is a template of instructions which is used to create containers. The Docker container is an executable package of applications and its dependencies together. And then finally, the Docker registry is a service to host and distribute Docker images among other users. So you'll also be asked to provide what are the advantages of Docker over virtual machine. And this is something that comes up very consistently. In fact, you may want to even extend it as having what are the differences between having a dedicated machine, a virtual machine, and a Docker or Docker-like environment. And really, the arguments for Docker are just absolutely fantastic. First of all, Docker containers occupy significantly less space than a virtual machine or a dedicated machine. The boot up time on Docker is significantly faster than a VM. Containers have a much better performance as they are hosted in a single Docker image. Docker is highly efficient and very easy to scale, particularly when you start working with Kubernetes. Easily portable across multiple platforms. And then finally, for space allocation, Docker data volumes can be shared and reused among multiple containers. The argument against virtual machines is significant, and particularly if you're going into an older environment where a company is still using actual dedicated hardware and haven't moved to a cloud or cloud-like environment, your arguments for Docker are going to be very, very persuasive. Be very clear on what the advantages are for Docker over a virtual machine, because you want to be able to succinctly share them with your team. And this is something that's important when you're going through the interview process, but also equally important, particularly if you're working with a company that's transitioning or going through a digital transformation where they aren't used to working with tools like Docker. You need to be able to effectively share with that team what the benefits are. So how do we share Docker containers with different nodes? And in this instance, what you want to be able to do is leverage the power of Docker Swarm. So Docker Swarm is a tool which allows the IT administrators and developers to create and manage clusters of Swarm nodes within the Docker platform. And there are two elements to the node. There's the manager node, and then there's the worker node. The manager node, as you'd assume, manages the entire infrastructure, and the worker node is actually the work of the agent as it gets executed. So what are the commands to create a Docker Swarm? And so here we have an example of what a manager node would look like. And once you've created a swarm on your manager node, you can now add worker nodes to that swarm. And again, when you're stepping through this process, be very precise in the execution part that needs to be taken to be able to effectively create a swarm. So start with the manager node, and then you create a worker node. And then finally, when a node is initialized as a manager node, it can immediately create a token, and that token is used for the worker nodes and associating the IP address with the worker nodes. Question 17, how to run multiple containers using a single service. It is possible to run multiple containers as a single service by using Docker Compose. And Docker Compose will actually run each of the services in isolation so that they can interact with each other. The language used to write out the compose files that allow you to run the service is called YAML, and YAML stands for yet another markup language. So what is the use of a Docker file? So a Docker file actually is used for creating Docker images using the build command. So let's go through and show on the screen what that would look like. And this would be an opportunity where if you're actually in a technical interview, you could potentially even ask, hey, can I draw on a whiteboard and show you what the architecture for using the build command would look like and what the process would look like? Again, when you're going through an interview process, as someone who interviews a lot of people, one of the things that I really like is when an interview candidate does something that's slightly different. And in this instance, this is a great example of where you can stand up to the whiteboard and actually show what can actually be done through actually creating images on the whiteboard very quickly, little square boxes where you can actually show the flow for creating a build environment. As an architect, this should be something that you are comfortable doing, and by doing it in the interview, and certainly you want to ask permission before you actually do it, but doing this in the interview really helps demonstrate your comfortable feelings of working with these kind of architecture drawings. So back to the question of creating a Docker file. So we go through and we have a Docker file that actually then goes ahead and creates the Docker image, which then in turn creates the Docker container. And then we are able to push that out up to a Docker Hub and then share that Docker Hub with everybody else as part of the Docker registry with the whole network. So what are the differences between Docker image and Docker containers? So let's go through the Docker image. So the Docker images are templates of a Docker container. An image is built using a Docker file, and it stores that Docker file in a Docker repository or a Docker Hub. And you can use Docker Hub as an example. And the image layer is a read-only file system. The Docker container is a collection of the runtime instances of a Docker image, and the containers are created using Docker images, and they are stored in the Docker daemon, and every container is a read-write file system. So you can't replace the information, you can only append to it. So while you can actually use YAML for writing so a question you can be asked is, instead of YAML, what can be an alternate file to build Docker Compose? So YAML is the one that is the default, but you can also use JSON. So if you are comfortable working with JSON, and that is something that you should be get comfortable with, is you want to be able to use that to name your files. And as a frame of reference, JSON is a logical way of being able to do value paired matching using a JavaScript-like syntax. So you're going to be asked how to create a Docker container. So let's go through what that would look, and we'll break it down task by task. So the task is going to be create a MySQL Docker container. So to do that, you want to be able to build a Docker image or pull from an existing Docker image from a Docker repository or hub. And then you want to be able to then use Docker to create a new container, which has MySQL from the existing Docker image. Simultaneously, the layer of read-write file system is also created on top of that image. And below at the bottom of the screen, we have what the command lines look for that. So what is the difference between a registry and a repository? So let's go through that. So for the Docker registry and repository, For the registry, we have Docker Registry is an open source server-side service used for hosting and distributing Docker images, whereas in contrast, for repository, it's a collection of multiple versions of a Docker image. In a registry, a user can distinguish between Docker images with their tag names. And then finally, on the registry, Docker also has its own default registry called Docker Hub. For the repository, it is a collection of multiple versions of Docker images. It is stored in a Docker registry. And it has two types, a public and private registry, so you can actually create your own enterprise registry. So you're going to be asked, what are the cloud platforms that support Docker? Really, list them all. We have listed here Amazon Web Services, Microsoft Azure, Google Cloud, Rackspace, but you could add in there IBM, Bluemix. You could put in Red Hat. Really, any of the cloud service providers out there today do support Docker. It's just become an industry standard. So what is the purpose of expose and publish commands in Docker? So if we go through, expose is an instruction used in Docker file, whereas publish is used in Docker run command. For expose, it is used to expose ports within a Docker network, whereas with publish, it can be used outside of a Docker environment. For expose, it is a documenting instruction used at the time of building an image and running a container, whereas with publish, it is used to map a host port to a running container port. For expose is the command used in Docker, whereas for publish, we use the command -p for when we're doing our command line used in Docker. And examples of these are expose 8080, or with Docker, we would put in, or for publish, we would do the example Docker run -d-p and then 0.0.0.80, 80:80 as our command line. So let's look at continuous monitoring. So with continuous monitoring, how does Nagios help in continuous monitoring of systems, applications, and servers? And so this is really just a high-level question of using Nagios within your environment. And you should be able to just come back very quickly and say, Nagios allows you to help manage the servers and check if they're being sufficiently utilized and if there are any task failures that need to be addressed. And so there are three areas of utilization and risk that you want to be able to manage. This is being able to verify the status and services of the entire network, the health of your infrastructure as a whole, and if applications are working properly together with web services and APIs that are reachable. So the second question you'll be asked is, how does Nagios help in continuous monitoring of systems, applications, and services? So it's able to do this by having the initial Nagios process and scheduler and the additional plugins that you would use for your network connect with the remote resources and the Nagios web interface to be able to run status checks on a predefined schedule. So what do you mean by Nagios Remote Plugin Executor, or the NPRE of Nagios? So NPRE allows you to execute plugins on Linux Unix machines that allow you to do additional monitoring and machine metrics such as disk usage, CPU load, etc. What are the ports used by Nagios for monitoring purposes? In this example, there are three, and they're easy to remember, so I would memorize these three, but they're essentially ports 5666, 5667, and 5668. So there are two types of checks within Nagios. So you will be asked for what is an active and passive check in Nagios. So an active check is initiated by the Nagios process and is run on a regular schedule. A passive check is initiated and formed by an external application or process. So this may be where a system is failing. And results are submitted to Nagios for processing. And to continue with this, for what is an active and passive check, active checks are initiated by the check logic within the Nagios daemon. Nagios will execute a plugin and pass information about what needs to be checked. Plugin will then check the operational state of the host or service and then process the results of the host or service check and send out notifications. In contrast with the passive check, it is an external application that initiates the check. It writes the results of the check to an external command line file. Nagios reads the external command file and places the results of all passive checks in a queue for later processing, so you can go back and revalidate. And then Nagios may send out notifications, log alerts, etc., depending on the results that they get from checking the information. So you're going to be asked to explain the main configuration file and its location in Nagios. So the main configuration file consists of a number of directives that affect how Nagios operates. So consider this as the configuration file that is read by both Nagios processor and the CGIs. So this will allow you to be able to manage the main configuration file that's placed into your settings directory. So what is the Nagios Network Analyzer? And again, hold out your 4 fingers because there are 4 options here. So the Nagios Network Analyzer 1 provides an in-depth look at all your network traffic source and security threats. 2 allows system admins to gather high-level information on the health of your network. 3 provides a central view of your network traffic and bandwidth data. And then 4 allows you to be proactive in resolving outages, abnormal behavior, and threats before they affect critical business processes. So what are the benefits of HTTP and SSL certificate monitoring with Nagios? So with HTTP certificate monitoring, it allows you to have increased server and services and application availability, obviously very important, fast detection of network outages and protocol failures, and allows web transaction and web service performance monitoring. The SSL certificate monitoring allows you for increased website availability, frequent application availability, and provides increased security. So explain virtualization with Nagios. So in response to this, the first thing you should be able to talk about is how Nagios itself can run on many different virtualization platforms, including Microsoft Visual PC, VMware, Xen, Amazon EC2, etc., etc. So just make sure you get that right off the bat. Nagios was able to provide capabilities to monitor an assortment of metrics on different platforms. It allows for quick detection of service and application failures, and has the ability to be able to monitor against many metrics, including CPU usage, memory, networking, and VM status. So name the 3 variables that affect recursion inheritance in Nagios, and it is name, use, and register. So name is a template name that can be referenced in other object definitions. Use specifies the name of the template object that you want to inherit its properties and variables from. And register indicates whether or not the object definition should be registered to Nagios. And on the right-hand side of the screen, we have an example of what that script would look like. Again, you may want to be able to memorize this, as it's something that you can actually write down and show someone if you're going through a technical interview. So why is Nagios said to be object-oriented? And fundamentally, it comes down to the object configuration format that you can use in your object definitions. It allows you to inherit properties from other object definitions, and this is typical of object-oriented development and is now applied for the Nagios environment. So some of the objects that you can inherit are services, hosts, commands, and time periods. So finally, explain what is state talking in Nagios. And so there are really 4 options here when you're talking about state stalking. So state stalking is used for logging purposes in Nagios. It allows you to enable for a particular host or service that Nagios will watch over very carefully. It will log any changes it sees in the output of the check results, and then finally helps the analysis of log files.
So we have come to the end of our Kubernetes full course. You have learned how Kubernetes works, how to manage and scale applications, and even some advanced tips to boost your skills. With this knowledge, you are ready to dive into the world of Kubernetes with confidence. Thanks for joining and best of luck in your Kubernetes journey.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.